know the 5-number summary quickly and easily. As always, least to greatest. Laura, 1,000 points right there. And let's do this.
I found him. What's he doing? I don't know.
The 5-number summary is the following values.
He's talking to someone.
From least to greatest, min, Q1, median, Q3, and the max. Nice answers. If you put the 5-number summary in the chat, you get 1,000 points. Keep these answers coming.
What is it? What happened?
What's up, everybody? I just finished my lunch, so we are ready to go. How are you doing today? Thank you, Houston, right there saying insane edits. Got my lunch ready to go. Lunch, dinner, I don't know what time it is. Brandon's asking any Titans fan in the chat. Let me go to live chat. Everyone's saying some great answers in the chat right now. We are streaming live. Who wants some points here? I think Mewbot's awake. Let's see if Mewbot can give out those 100 points. Merrick, good to see you here. Natasha, good to see you here. Let's put on a little chill music. We're gonna get started up reviewing some Stat 1. Lauren, good to see you. Megan, good to see you. We're doing great. Zaid, JB, good to see you too. Emily, good to see you. Macy, good to see you. Mary, good to see you. Tiffany, good to see you. Jace, good to see you. Cameron, Kayla, Alyssa, Rachel, Reese, Nicole, Zaid, Mackenzie, Stone, good to see you. Everyone checking those points right now. See how many points they got. Okay. So what we got going on? Other than awesome milkshake done. That's it. What's up, Aaron? Good to see you here. Trevor, good to see you here. Mark, good to see you here. Nicole, good to see you here. Andrew, good to see you here. We're going to start with Chapter 1, a very good place to start. Who you got in the Titans Seahawk game? Ooh. Oh, you know what we do? We need to send out one more announcement on Discord. So let me go to Stat 1 Discord. And let me message. You're probably going to see this in your Discord. Reviewing live right now for Test 1. Okay, we put that in there. We're good to go. Got the chat on the screens. Derrick Henry needs to be picked up. Ooh, maybe I got him on my team. My team in my league that I'm playing for money, my family league, has 56 to 55. I got Gronk, though. I saw Gronk got an early touchdown, it looks like. Tom Brady already hooking up. Ooh, wait. Wrong team. Okay, Patriots up 2-5. So, good job. Oh, not Patriots. Tampa Bay. Gronk has 2? Can't go wrong with Gronk. Got him like 7th or 8th round right there, Trevor. I tell you what. Will this be recorded? Yes, this is going to be recorded. It's recorded now. Everything is recorded live here on Stat 201. Just chilling out. But you know what we're going to do? We're going to start with some Chapter 1. And I will tell you this. 1, the only way to do well on this test. Who knows the only way? Not the only way. Who knows one of the best ways to do well on this test? Who in the chat can tell Brian what is a great way to do well at this test? I'm predicted to play you round 1 of the playoffs. Ooh, Jason might have that. I mean, if we have to leave early, we'll just, yep, it'll be posted. Yep. Attend class, study, review, and keep doing your work. So here's one thing that I noticed. This is Brian's quick shout out before he gets everything going right here. Is I notice that when people do poorly on this test, they don't attend the next class. They say, you know what? I did poorly on the test. And the test is on Wednesday, and we're going to be reviewing Wednesday also. But then they say, you know what? I'll just not attend next Monday when we're doing brand new material. So don't do that to yourself. Don't say, you know what? I'm not going to attend class because then you're just setting yourself up for failure. I'll tell you straight up, I am going to be kind of scanning over some test questions as we do this and going through here and seeing if you can figure out what the questions are. I'm looking at some new ones right here, making sure I know all these. Not that I don't know them. Yeah. Let's check this out. Who's ready to start up some review right here? Who's ready? Because I got the review in my head. Then we're going to take that review and put it into your head. That sounds weird. We're going to get going right here with some review. Ready to do this right here? Everyone knows how to win. Come to class. Kayla's right there. Mark says, let's go. Let's do this. Little Stat 1 Hacker Man to get us started. Can't go wrong with some Stat 1 Hacker Man. Let's do this right here. You will know your score, I think, 24 hours after, because we're going to make sure everything's working. Let's hop over to the main screen and start some review. Okay, it is time for review, everybody. Let's do this. Chapter 1 is a very good place to start. There is going to be a Kahoot tonight. Join in for the Kahoot. $100 in prizes. Kahoot at 8 p.m. your time. So Chapter 1, all about those variable types. And, of course, all about those variable types and So, and randomness. Okay, so we got chapter 1, variable types and randomness. Who knows the 3 types of variables instantaneously? And this is what you want on your note cards. I can tell you everything. I can just rattle off facts. I can be like, quantitative variables are actual real numbers that we can take numeric differences between. That I can do. Kelsey's got some great notes right there. QCI, and I know Kelsey knows what they're talking about. Quantitative, categorical, and identifier. This is where you want to have in your notes the 3 different types of variables and be able to explain what they are. We're going to go into a little more detail on the subtypes here because we're going to be doing like as much as we can. So have your note cards out, especially flashcards or anything you want. If you want me to type something out, remind me to type it out. And once again, thank you for being here. I told Chelsea, I was like, I hope we at least have like 8 people. And I see there's like 50, 60, 70, 80 people watching or something. You're making my day right here. Let's throw out some points, Mubot. Okay, here we go with quantitative variables. Quantitative variables are actual real numbers. So we can do mathematics on them. So chat, go crazy as Brian learns how to type. Chelsea is dope. Mathematics on them. So show me some quantitative variables in the chat. What are some quantitative variables? Identifiers are subtypes of categoricals. Identifiers are special categoricals. 45 is, 7 is, and those are quantitative numbers, correct. But like your age, Zaid right there earning everyone another 20 points. Social security number would not be quantitative. It would be an identifier, but I'm throwing some more points out there. GPA is quantitative. Height is quantitative. A number of cows in a field is quantitative. So 45 Chick-fil-A nuggets is quantitative. Give me those quantitative Chick-fil-A nuggets right there. Social security number is an identifier. Just how far are you away from school? Think about this. We generally say how. Hints for tonight's Kahoot. When you think about a quantitative variable, it's a measure of how much. Number of apples. How many apples? Does that make sense? That quantitative variables are measures of how much. And you can do mathematical differences on these. So you can subtract different quantitative things like how much older is Brian than his students? 5 years, that's the answer. So I'm 25. So when you do these quantitative things right here, height, weight, income, they're all actual real numbers. But don't be confusing them with the things that try to trick you, where we do things like this. Now, one could argue this is how many years you are in school, but this is not sophomore. Yeah, that's how you spell it. I don't know, spell anything. What kind of variable is this? And this is where we're switching off right here. This is not quantitative because you'd be like, well, those are numbers. They're not categorical. Mary's right here. These aren't really quantitative anymore. They're categorical because we have what class are you in? Listen to the difference in the wording where we generally say how for quantitative. We say what, like what group are you in? Because it's a group, it's a quantitative, a category. And Casey's right there for another 20 points in ordinal. Now we'll get to identifier here in a moment. But with this, we have categorical variables. Put things into groups. We generally say what, like what group are you in? Like what group, and up here we say how much. Just the practice of what these are is very important. So we put these things into groups. We generally say what group, and it's just used to kind of put like-minded things together. Like freshmen are together, sophomores are together, people from North Carolina, people from New York, wherever you're from can be a categorical variable. You have to be careful because there are subtypes of categorical variables. The one I just showed you had an order to it. Do you get where I'm going with this? So what kind of variable was that thing I just showed you? It had an order to it. I think Casey knows what kind of variable it is. So what kind of variable is a categorical variable that has order to it? Ordinal, Ashley, and Savannah, great job right there. Nicole, excellent work. Ordinal categorical variables. Now, what does an ordinal categorical variable mean? I really don't know how to spell anything today. Ordinal categorical variables have order to them. Like steak preference. Goes from rare to well done. So when you think about steak preference, that's an ordinal categorical variable. Oh, Lucy, don't be sad. Cheer up, Lucy. 20 points out there. Cheer up, Lucy. So an ordinal categorical variable has order to it, like steak preference goes from rare to well done. Unless you say let's include vegetarian, that would not be on an ordinal scale. So we don't really consider ordinals numeric. Even if we give them numbers, if we say like an ordinal number, it's still categorical. Hint, hint, hint for Kahoot tonight. So we wouldn't think of an ordinal variable as quantitative. It is categorical. More on that later. The other type is what? Who knows from some 20 points the other type of categorical variables? What is the other type of categorical variables? We have either something as ordinal or it has no order to it. Ashley, great job. Nominal. And the best way to think about these, let's highlight some cheats for them so we can remember these. So when you hear ordinal, think has order. When you think nominal, think has no order. Does that make sense to keep them straight? Ordinal, nominal. The no of it, not the nom, but the no of it. No order or either order. So think of it in that way. It's either ordered or it has no order to it, and it's nominal. So the nominal categorical variables are simply categorical variables that have no order. 24 questions on the Kahoot tonight. We'll have some fun. It'll be good fun. Prizes. So with this right here, you guys are crazy in the chat. With this right here, we have, can you post the Word doc to Canvas? Yeah, I can try it. Yeah, I can do it. Make sure to post it here. Definitely, definitely. So we have here the ordinal categorical and the nominal categorical. It is worth mentioning, and I don't think these appear, but I'm just going to mention it. Kahoot's at 8 p.m. We have here discrete, and these are whole numbers, like 1, 2, 3, 100. And we have here continuous. US. Oh, that's a word I never know how to spell. Continuous just means can have decimals. We're going everything right here. So these are continuous numbers right here. Things like that are a continuous number. Last but not least, we have a final variable type. Who knows the final variable type? Who knows the final variable type? Who knows the final variable type? And then you'll know all your variable types. An identifier. Now, identifiers are special case whats. You're on track. You're getting these things down. You're practicing. You put it in the chat. You're feeling quantitative categorical identifier. Quantitative categorical identifier. I need to like loop that on my loop machine right here. Identifiers. Yeah, we'll do it. We'll give examples of each here. Kylie, you got it. A nominal would be something like what state are you born in? Because there's no order to it. So that'd be a nominal. Since there's no order, like what state are you born in or what's your favorite ice cream flavor would be nominal. Since it doesn't have an order to it, like chocolate and strawberry are not ordered. So identifiers are what? They are special case. Great job, everyone in the chat. Special case categorical variables. They can not, they will not, they won't stop what? Ever whatting. They can't stop. They won't stop. They're not going to ever do this. They're not going to do this. You can't have a boom right there. Mark knows. They won't repeat. Ever. That's the point of them. What does an identifier do? Just what does an identifier do? It identifies. So if it repeats, it can't identify. Zaid, Kylie, Savannah, everyone, Hunter, great job right there. It identifies. So if it repeats, it can't identify. Like social security number. It's like, oh, you have the same social security number as me? That's weird. It's not good. So an identifier can't identify if it repeats. So that's the intrinsic quality of it. That's why it exists. Jersey numbers. Well, jersey numbers, yes, for a team. Jasmine, great answer right there. Because then you've got like your team and your jersey number, and then also the year, which would identify the player. Think about that, Jasmine. Like team, year, and jersey number would identify a player. Like 23. Like who knows who this is? The Bulls, 23, 1996. The Bulls, number 23, 1996. Who does that identify right there? Any thoughts? Bulls, 23, 1996. Shaq. Was Shaq with was he for one season? Shaq and Jordan were a little like Shaq started off. Oh, there we go. People know some better numbers than I do. Jordan, that's some MJ right there. That's some Michael Jordan. We're about to have that Jordan. Can't think of his. Wait. LeBron chat and chat. Gronk, that's not Gronk. That's not Gronkowski. There we go. Exactly. That would identify. So the number alone, the jersey number alone would not be an identifier. Interestingly enough, jersey number by itself is actually a what variable here. Be very careful. That's actually a very hard question. Jersey number by itself is a what variable? Jersey number by itself is a what variable? That's a tough one. Mark, great job. Mark is right. It is nominal categorical. Because you don't, does that make sense? Like a jersey is not how much, like how much, you wouldn't say how much is your jersey. Does that make sense? You'd say kind of like, what is your jersey number? You could say, you just don't, like, you could say, what is your jersey number? But it's not really a number. It's just like, I am someone who wore jersey 23. And then we could look to see if people do better on a certain jersey number. Who was 91 on the Bulls? I don't know. Does that make sense? How it's, and then there is no, even though they're ordered, there's no intrinsic, it doesn't matter to what order they are. Like one isn't actually higher than two. They're not meant to show that someone is a higher number, even though they, like, someone might have arguments over these two. It's definitely categorical though. Does that make sense? Like, what is your jersey number is the way we would ask it. And then someone would say, oh, my jersey number is more than yours. You'd say, no. What number was Rodman? Nope, doesn't mean a size, Aid. It's just like a player identification on a team. Dennis Rodman was 91. Gosh, I'm old. I remember Dennis Rodman playing like it was yesterday. I'm old. But who has questions on these? We're about to do some randomness here. We've covered a lot of different questions. Like, let me ask you right now. You ready? Let's try a true false question or two. Here we go, everybody. Time for a little Stats 1 Hacker Man. Let's do this. Test your knowledge here. Test your knowledge time on this. Here we go. Get ready in the chat. True or false? Oh, we could do it right here. True or false? Do not choose true or false yet, because I haven't told you the answer to the question yet. Don't do true or false yet. First question comes up right here, and the question is, someone's probably already answered true or false. Oh my gosh, I hit the new button. Okay. Something that is a number is always quantitative. Thank you, everyone, for not answering right away. I appreciate it. I was waiting for someone. Something that is a number is always quantitative. Something that is a number is always quantitative. You can see which way the question. I'll try to trick people right here. People saying false in the chat. Let's see how many people responded. I'm so proud with how many people are watching and following along. And I'm just around 100 points. I don't care. People are following along. People are practicing right here. Let's end the poll. I might just do it via the chat. I like seeing chat go crazy. The answer is false because we've 105 people. Great job being here on Sunday reviewing. Excellent work. Going to make it worth your time. We're just going to topic. This is definitely false. 100% false, because you can easily do something like what state you're born in and label it state 1, state 2, state 3. So there's many ways to make things that are quantitatives that are categories. Let's go here. An identifier is a special case quantitative variable. True or false? Go crazy in the chat. Let's see what people got. Go crazy right here. Go crazy in the chat. I want to see that chat go fire. We like it when chat goes fire right here. Chat is going fire. Chat, that's too easy. I'm going too easy on everyone. Because it's false, because an identifier is a special case categorical variable. Chat, excellent work right there. Lauren, Mark, Grace, Catherine, Gracie, Michaela, you all know the answer, that it is false. Try to make this more difficult. Maybe Brian's going to look over here for a half second. Those are those. That's too easy. Okay. Actual real numbers are represented by quantitative. 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 Oh, man. If everyone gets hundreds on the test, YouTube will complain. Let's make them complain. They won't complain. I mean, maybe they would. I don't know. Oh, this is so easy. What does all data need? Oh, you got this. Come on, this was on your Canvas content. Destroy it. Be like, Brian, you said this a billion times. I'm just saying, I mean, I know what's on the test, and I'm not saying, we've covered these things a lot. When you get to that test, I want you to take the test, and then the day after the test, I want you to tell people, does Brian's reviews help? Does coming to class help? We're going to take data on this in next class. I believe I'm going to have us take some data, but you can see these are things we covered, and maybe I'm making sure that we're focusing in on some ideas, because there's not too many big ideas for this right here. We do have to talk a little bit about randomness. We've got about 5-10 more minutes on this topic. We're trying to do like 25 minutes on each. This isn't the biggest of chapters, but we need to mention some randomness right here. So what's the deal with randomness? What's the deal with randomness? Worst Seinfeld impression ever. That's what it is. So randomness. Randomness is considered a what by statisticians? Some key stuff right here from the slides. Randomness, statisticians consider randomness a what? Statisticians consider randomness a what? Like, we like it. We love some randomness. What do statisticians consider randomness? Probably someone's favorite band. Boom, Mark right there knows. I was going to say someone's favorite band, chat. We consider it a tool. We consider it something that'll help us. See, look at everyone paying attention and like there. So randomness is considered a way to collect data, a way for us to check results. And one big way we talk about right here is we have a population, we have a parameter, we have a sample, and we have a statistic. Does anyone remember what comes after this? Does anyone remember this from the start? We're going way back to the start, way back 4 weeks ago. I mean, it's kind of there as a hint. And I'm going to review what these terms mean. Who knows PPSS? Marjorie, great job. Some 20 points in the chat right there. PPSS means population parameters, sample statistics. And I think we complicate what these words mean. Let's go for the easiest, low-hanging fruit ones. Population is going to be the group of people or things we want to what? The group of people or things we want to what? So if we have a population, it's the group of people or things that we want to what? Kind of, Mark, you're on the right track. We want to do this. We want to. People are correct. We will get a survey out on them, analyze or understand a lot. Boom, Kelsey right there getting another 20 points. I would say understand. There's a lot of synonymous words. Like, this is the group we want to learn more about. Study, analyze, better understand, learn about. Does that make sense? This is our population, sometimes called of interest. I'm going to put right here beside this of interest, because you'll hear people just throw that on. The population of interest is the same thing as the population. It just means you're interested in them. Statisticians like to add extra words. Now, parameter is where people get confused, so let's come to that one back here in a moment. The sample, and what we're going to do to these is we are going to make them some cool colors, and we're going to show that the sample is basically the population and the sample are sort of the same thing right here. As in, the population is the group of things we want to understand, so the sample is what we collect data on. The sample is what we collect data on to do what? Or what we collect data on. Mark, great job right there. What we collect data on to understand the population. Does that make sense right there? Like, how exactly this is the case of Kayla right there. This is, we collect data from a sample to understand the population. So the sample is the insight into the population. Now, parameter and statistic are going to be linked also. Let's kind of do a little help right here so that when I make it, we're going to change colors, make it look all pretty right here. And so when we talk about a parameter, the parameter, I think my nephew Tolliver is calling. Wait, watch this. Tolliver, I'm on the internet. You want to say hey to the internet? Woo! Bye, Tolliver. I'll talk to you later, man. Bye. Say bye, Tolliver. Oh, wait. Yeah, we'll play video games later. Play video games later, Tolliver? What time? Are you free tomorrow night, Tolliver? Are you free tomorrow night? Ask mommy and daddy if you can play tomorrow night. All right, we'll play video games tomorrow night. You up for that, Tolliver? Yeah, that's good. Awesome. Say bye to the internet. Bye, internet. Bye. Okay. There we go. We'll play some internet. Coot's canceled. Coot canceled. He goes to bed. Oh, there we go. We'll play some video games tomorrow night after class. There we go. He's a good. I knew it'd be him, and I don't want to ignore his calls. I don't want to be like Uncle Brian doesn't answer my calls. Gotta answer the calls from the Tolliver. Let him. So there we go. Oh, thank you, everybody. Everyone's so happy and chat right here. Oh, he's a good little guy. I saw it was a FaceTime, and I was like, my brother doesn't FaceTime me. My nephew FaceTimes me. Oh, here we go. Okay, so what's a parameter? So a parameter right here. So the parameter is what we want to understand about the what. The parameter thing, let me separate this out a little bit more. The parameter is the what. The parameter is what we want to understand about the what. The population, exactly. The population. So remember, we're going to collect data from a sample to understand the population. And what we want to understand about the population is the parameter. So what we want to understand about the population. Like imagine you want to know, is parking bad this semester? That would be the what. For like, you want to understand that about UT students. You want to know what % think parking is bad. So you want to understand what % of students think parking is bad. That % of students who think parking is bad is the what. It's so bad, right? It's all, sorry. 100%, that's the answer. So the % of students who think parking is bad is the what for the population. That, because like you want to understand that. That's the parameter you're interested in understanding. That's the what you want to know about students. Does that make sense? Don't need statistics. Benjamin right there. You don't need stats for that one, right? So what you would do, though, is you'd go out and talk to maybe 100 students, and that 100 students would be your sample. Does that make sense? 100 students are going to be your sample, and then this is going to be our estimate of the truth for the population. So if we went out and talked to 100 students, those 100 students would be our who. So if we went out and talked to 100 students, those 100 students would be our what right here. The 100 students we talk to will be our what. They would be our sample. Does that make sense? And we are using these students to understand the population. And then, Kale, you're basically right. The parameter is what we completely want to understand about the population. And then if the 100 students tell us 95% of them hate parking, would that be a statistic or a parameter? If 95% of our 100 students hate parking, would that be a statistic or a parameter? If 95% of our students hate parking, that would be our statistic or a parameter of the 100 we talked to. That would be a statistic because it came from the 100 student sample. Then we would use this information to estimate the truth for everybody. Does that make sense? How we talk about the population parameter, which you can call it the population parameter, is like what all students think about parking. So let's add a thing right here. Views of all students on parking. And so that would be the parameter of interest. Like, what do all students think on parking? That's what we want to understand. And this would be all students. So the all students right here is the population. It's some characteristic of the population. The sample is going to be 100 students we speak to. And then right here, and then right here, this is going to be the views of the 100 students. So we use this, and this is called what kind of statistics? 100 points on the line right here. This is called what kind of statistics right here to make inferences. To make inferences from a sample to a population to say, okay, this sample is going to allow me to estimate some truth for a population. We call this what kind of statistics to make inferences. So we're going to use this sample right here to make inferences about the population to say, oh, from the sample we learned this, so this is a good guess of what the population thinks. So we call this future to make inferences We call it inferential statistics. Inferential statistics. So inferential statistics, great job right there. So this is the whole idea of inferential statistics, and we take these random samples. So we use random sampling right here, and the ways in which we do random sampling, I kind of mentioned it here because we're going to get to the next topic in a second. So, hit a new thing. Okay. Random sampling. Humans are really bad at random sampling. We often use computers and random number tables to generate random numbers. That's about a really good review of the randomness. And yeah, I think that's got it for the first chapter. And I want to mention this is just the start of our review right here. Any last questions? That's really just some stuff on randomness. Good talk on some key terms right here. I'll just disappear so you can see it all. I will post this all later, but taking your notes, being here practicing, we're going to keep doing review questions for each section, and the difficulty is going to go up each time a little bit. So great job. Who's ready for, this is the review for Stats 101. Good to see you here, Ditto. Excellent stuff. Let's head back here to the main screen. If you got questions, can we do practice questions for chapter 1? Well, let's do a few more. Yeah, let's do a few more right here. Let me think up a few more right here. So let's see here. Let's say right here. You ready? Here we go. Once again, some Stats 1 Hacker Man. Let's do this. Here we go. Time for some questions. When creating a list of random numbers, you should pick the random numbers yourself. True or false? When creating a list of random numbers, we'll be getting some chapter 5 here soon. When creating a list of random numbers, you should pick the random numbers yourself. Correct. You should use computers. Use computers or random number tables. Let's go right here. Another question is going to be, could be, things like this. Random events can be equally likely or not equally likely. True or false? Random events can be equally likely or not equally likely. So here's what you want to do when you get a question like this. You want to think, do I know of an instance where they can be equally likely? Who can tell me an instance? A lot of true or false in the chat right now. Who can tell me an instance of when a random event could be equally likely? We could use a billion. What is an instance of a random event that is kind of equally likely? Flip a coin right there, Alyssa. Great answers. We'll flip a coin, some equally likely right there. Who can tell me a random event like, oh my God, when you get that ticket and you win $1 million, winning the lottery would be a not equally likely event. Winning the lottery would be a not equally likely event. So this is definitely what, chat go crazy right here for some 20 points. This is definitely a what statement. This is definitely a what statement. 100 million% true right here. This is definitely true. We could use sided dice, and then then each one might be equally probable. There you go. That'd be cool if someone made one of those, but that would just like fill up the whole universe maybe. Well, that's got it. Let's head back to the main screen right here, and let's do this. We're on the main screen, and we're about to start some chapter 2. So chapter 2, I'm going to pull up the review. If you didn't know, we've got the review page right here. It's like an advertisement. We've got the review 1 page right here, and the review 1 page, Mubot, tell us all about that review 1 page. Mubot, where you at?
Anytime you want to go to reviews, just ask me. I know where all the reviews are at. Review 1 can be found here. Brian, bring that page to the main screen and show them. Thank you, Brian. Mubot out.
Well, thank you, Mubot. Let's go check that out. So we're pulling up. As you can tell, chapter 1 didn't have much to it, so we covered pretty much all of chapter 1, but now we're starting off on some chapter 2. So we got a lot of this done right here. Really great review in like 20, 30 minutes. Check out the other videos if you want. They are on the review page, but now we're going down to here, and we can't say he's doing well.
I am Mubot.
Let me just chill out a little bit. But now we're getting into some tougher stuff. What are people most interested in here? Starting chapter 2 right now. This is where we just take a little jump in difficulty. And I want to show you probably one of the most important graphics. I show this a lot. I would highly suggest taking a screenshot of it. but this graphic right here probably has 10% of the points on the test. Like, knowing this information is probably 10% of the points on the test. Because we can go over here and we can do a question like this. Let's immediately hop to some chapter 2. And here we are. And chapter 2 is called Displaying and Summarizing Data. So, chapter 2. Very important graphic, you bet. Stem and leaves. Oh, let's check this out right here. You ready? Let's do the following. Let's start right here with let's do questions. Let's start with some questions. Stem and leaves display categorical variables. A stem and leaf displays a categorical variable, yes or no? And why false? Stem and leaves. What else displays quantitative variables? Because they're numbers, you're right. Great job right there, Mark and Caroline. Everybody, Macy, great job. They display quantitative variables. What else display? Histogram. What else? Dot plots. And also box plots. Great job right there, Chloe. So we've got all of these right here, which are ones you should know. These right here are your displays of quantitative variables right here. That's a little hard to see. It's a little too dark right there. So that's too light. This will be just right. Sure. So these are displays of quantitative variables. Does anyone know the displays of categorical variables? So here's your displays of quantitative variables right there. Key ones right there. What's going to be displays of categorical variables? What's going to be displays of categorical variables? Bar charts. Bar charts. We need to change colors. Bar charts. If you have bar charts, you want some pie charts. Ring charts. It won't do that. There we go. Ring charts. No one likes ring charts. Oh my gosh, Zaid, great job. Frequency tables. And then I think Zaid threw in, we got to put, guess what? Pareto will go over here. All display univariate categorical data. So these are all univariate displays of categorical data right here. And we'll just start highlighting. Now, no one likes ring charts. Not a big fan of ring charts. Sorry, ring charts. But what's the deal with a Pareto? People forget Paretos. What's the deal with a Pareto? Who can explain a Pareto right here? Who can explain a Pareto? They're going univariate. Means one variable. Pareto. Wait, what's that Pareto? Oh, relative frequency. Yes. Relative can be added to most of these, and then they are out of percentages or decimals. Great answer right there. That's some 20 points. Yes. Pareto just comes from the highest to left. The bar is correct. Pareto is a bar chart that lists them in order from most to least common. Exactly correct right there. So we can see some of these graphics. I'm going to pull over some data. If I go over here to analyze distribution and I analyze something like high school GPA, what kind of display will I get? High school GPA, because that's how much is your GPA. Are they actual real numbers? Paretos are more like bar charts, more bar charts. So if I analyze high school GPA, what graphics will I get? Because it's quantitative and it's one variable, univariate quantitative displays of data right here. So what am I going to get when I analyze high school GPA? I'll get what? Or when I analyze number of pets people own. I'm going to get a histogram. Because remember, histograms are for quantitative. So it might look a little like a bar chart, but that is a histogram because it's quantitative. And a good way to tell if it's a histogram is you'll see on the bottom of it the number scale on the bottom. Now I want to point out some important stuff right here. And let's see right here. We got two different types of graphics. And they're not perfect, but I'll take it. With these two graphics, I chose them for a certain reason here. Good. I'm trying to make them a little smaller so you can see the numbers. When you look at the histogram, there are three things we talk about for this. And write this down. Univariate quantitative data has 3 ways we describe it. Who knows in the chat for the 3 ways we describe univariate quantitative data? That means we're just analyzing one variable. We have 2 univariate quantitative displays of data right here. Kayla's helping out, 20 points. I missed a question maybe. Thank you, Kayla. So, Kelsey right there's got it. Shape, center, spread. Shape, center, spread. So outliers will be part of shape right there. Savannah, great work. Savannah, excellent work. Another 20 points, Savannah. Shape, center, spread. This will be important because when we get to chapter 6, which we'll be reviewing at the end right here, we'll have other ways. I don't want to mention them now. Just want to focus on this. But we have shape, center, spread. Now, when you talk about the shape, first thing we talk about is the modality. Both of these are what? When you look at the modality of these, which is the central area of data, both of these are what when it comes to the data. So the first thing for shape is going to be the modality. Let's write this on our review sheet. So univariate quantitative data. And so we have over here shape. Make sure to mention modality. And people should have noticed that both of these right here are univariate. One mountain. I like that right there. Like these aren't little mountains over here. They're one mountain. Now you have to know the difference between unimodal. I think I might have said univariate by accident right there. Unimodal and uniform. A uniform distribution looks like this. Does that make sense? How it's one form that is uniform, and then there is unimodal, and then there's bimodal or slightly bimodal. The better the peaks are, the stronger the modality. So modal just means like area of concentration of data. So the first thing we mention is the modality. Next, mention the what. Think of a face right here, the what of it. Next, mention the what. So next we'll talk about, or the lack of it, the skew or symmetry. So now we're going to talk about skew or symmetry here. So let's go look at this. The top one right here is mostly what? This one up here I think is a little bit easy. This one right here, chat, I want you to go crazy. I want chat following along at all times. I can say every single answer, but you have to be like, okay, that's unimodal, mostly symmetric. Great job right there, Julia, Ashley, and Kelsey. Excellent work. And Alexander and Demetrius, excellent work. And then this one down here is very obviously what? Now we got to remember how it works. Here's our famous saying, right to the high, left to the low. People know whatever way. Right to the high, left to the low. It's right skewed. Whatever way the tail goes, draw your little monster man. Right to the high, left to the low. Kylie's got it right there. Right to the high, left to the low, whatever way the tail goes. Julia's got it correct right there. Right to the high, left to the low, whatever way the tail goes. Now, when things are skewed, big thing right here. You ready? These are the big things. When things are skewed, what will follow the skew? And hint, you can look. There's this and there's this. When things are skewed, what will follow the skew? The mean will follow the skew. So the more symmetric things are, the closer the mean and the median will be to each other. The mean and the standard deviation will be inflated too, but the mean will follow the skew. And the standard deviation will also be unreliable. More on that in a second. But we have right here the shape of the distributions, and we know here that the shape, the mean will follow the skew. The mean will follow the skew. And take a look right here. The mean is right here, 1.23, is higher than the median of 1. So the mean is following the skew. And so now, let's go back here to our sheet, and we have the shape, outliers and gaps. Now, both of these have outliers and gaps. Both of these distributions right here. Here's a bunch of outliers here. Here's outliers down here. There's a large gap. There's a ridiculously large gap. There's an outlier. And it's kind of worth mentioning these at some point. Like someone owns 33 pets. Is not it median with skew? If there is, I know what you're getting at, Zaid. Yep, I think we'll be doing that. Which question, Kayla? I'm going to slow down right here. Are people on track? I don't want to go too quickly. If I ever go too quickly, slow me down. Which question were people wondering about? When things are skewed, because I think you're getting to the topic of center, that's where we'll use the median. Correct. I think that's what you're saying. Is that correct, Kayla and Zaid? When things are skewed, the proper measure of center is going to be the median, which I think that's what you're asking about, right? Let's see what people say. I think that's what you're saying. Yep, you are 100% correct, because that brings us to the next topic. After we get done talking about the shape, we need to then talk about the center. And the center of the distribution decided by shape. So when it's skewed or outliers, when it has skew or outliers, what do we use then? And the mean does follow the skew. That's why you don't use it. So, Kayla, sorry for confusion right there. So when the mean does follow the skew, that's why you don't use it, because it's unreliable then. And median people are correct. We use the median right here. If it is or versus normal looking, we use mean. So we either use the mean or the median, and you have two choices right here. When it is skewed with the outliers, so the more skewed with outliers it is, you use the median, and the more normal looking it is, you use the mean. But it is true, so I think this is where the confusion. Bimodal, I might go median. We probably won't throw that on the test. How bimodal? If it's very bimodal symmetric, Savannah, good question, 20 points, Savannah. Then it might be iffy. If it doesn't have extreme outliers, I might still go mean. Those are the iffy ones right there. So this right here is how we pick between which one to use. And think about this. Let's look at our example again. The reason we wouldn't use the mean right here is because the mean is being inflated due to the outliers. That makes the mean unreliable. So down here on this bottom graphic, what is the proper measure of center? That's kind of this top one's a bit odd, Zaid. So good question right there. So you can get kind of symmetric outliers up here. The proper measure of center down here is going to be what? The proper measure of center down here is going to be what? Definitely the median. This is quintessential median. And you're only picking between mean or median. Those are your only two choices right here for proper measure of center. And that is quintessential. Like, that is perfect. Now, I wish the top one looked a little more perfect. If I were to show you this right here, if I were to show you this graphic, pretend this is the graphic you see up top, because we like to do things that are a little bit nicer on the test, because we're going for like the more exact knowledge, not the iffy ones. If you saw this right here, what would you use up top? For the top one, what is the proper measure of center with that right there? For that one right there, the mean, because it looks more unimodal and symmetric, which is the normal shape. So since it doesn't have extreme outliers and it doesn't have skew, the mean is going to be the proper measure of center. Great answer. People are measuring mean and standard deviation. Standard deviation is going to be a measure of what? Standard deviation, which you see right here next to the mean, standard deviation is going to be a measure of what? Standard deviation is going to be a measure of what? Standard deviation is going to be a measure of spread. And once again, it's decided by the shape. So the standard deviation is inflated when there's outliers, so we don't want to use it. So we can talk about how the standard deviation changes in an undue way because of outliers. And because of that, on the bottom graphic right here, just look at the shape of it. What is the proper measure of spread and what is it? Try to calculate the proper measure of spread for this bottom graphic. And then what is it? Lots of review questions right here. Can you calculate the proper measure of spread for this graphic? And like, what is it and how much is it? And could you interpret it? What is the proper measure of spread for this bottom graphic? Demetrius is right. It's the IQR, and Jens and everyone, good to see you here. 20 points. And so how much is the IQR? Kelsey's right. It's 2. The IQR is 2 because it's the distance Q3 is from Q1. And the equation right now would be 2 minus 0. So that's the equation of the IQR right here. And so we should use the median of 1 and the IQR of 2, 2 minus 0. Now, it's not just because this is 2, it's just because 2 minus 0 is 2. And on the top graphic, the proper measure of spread will be the what? And think, since you said the mean, and I know there's some outliers here, we're going to say that those outliers are not too extreme. It's a little bit of an iffy one. But, yep, you are correct, Mark. That is correct. Standard deviation for the top graphic. Standard deviation for the top graphic. Now, this isn't a super tough question, but although we wouldn't be using it, can you calculate the IQR for this top graphic? So use the output right here and calculate the IQR. Someone's going to do it like super quick. If we gave you a small data set, you could find it. We could do some practice on that. Super quick answers right there. You know that the IQR is just this distance. And you can just subtract those numbers. So 4.0 minus 3.6 is the IQR. And so we would ask you maybe the things we could ask you on the test to find by hand. If we're asking you the IQR, we give you this output. We give you this output and you subtract those numbers. If we ask you the median, we could give you numbers, or we could give you numbers and ask you the mean. We won't have you do the standard deviation by hand. Standard deviation we never asked you to do by hand. So let's try a few ones of those real quick. Let's do the find the mean and find the standard deviation. Let's do it right here. Possible test questions, good practice. Find the mean and median. And this will kind of show what we got going on right here. So let's find the mean and median for the following data sets. 1, 8, 11, 20. What is the mean? What is the median? I didn't make it nice, did I? I'm solving this. Oh, I did make it nice. How about that? What is the mean of this data set? Kelsey's right. To find the mean, there we go. So the dividing by 4. The answer is 10. Great job, Jens. Everyone practicing in the chat. Yep, just make sure to double check when you enter in your calculator. Easy to make mistakes. So how do we find the median? How do we find the median for these? And Merritt is correct right there. And Benjamin's finding the spot for the median. The spot for the median, or it's, yeah, n plus 1. So it'll be the 2.5th position. That'll get you the position of the median. And so we never give too big of a number line for this. We always give you smaller number lines. Does everyone see how we're getting 9.5? Great answers in the chat. And people are explaining how to do it right here in the chat. Excellent work. Let's throw a little bit more difficult of a one. Let's do this data set right here. Okay, I'd like for you to find the median of this data set. So find the median, question mark. What is the median of this data set? Lots of different answers so far. Good job. And so what did I not do right here? What did I not do in this problem, which you're supposed to do, which we should also understand? When finding the median, put them in order. Exactly. So when you find the median, put them in order. And if you put them in order right here, 1, 3, 9, and 11, you would then average together these two numbers right here, and that's going to get you the median. So we never give you too big of data sets. We never go and give like 50 numbers. It's going to be smaller. We'll never ask for the standard deviation by hand, and we don't ask for the IQR by hand. You look at jump output for that right there. So good stuff on those. Another thing, let's do a few more questions. So, so Pareto charts. A Pareto chart is a histogram that has been put in order. Just 3 plus 9 divided by 2. Yep. So for Griffin right there, 3 plus 9 divided by 2. So add them together and then divide by 2. False. False. Oh, and Savannah. Great job, Savannah, right there. 20 points, Savannah. Savannah is saying, no, this needs to be bar charts. Because Pareto charts are categorical and bar charts are categorical. So make sure you have that. Good notes right there. Anything you make with a bar chart could be made with a pie chart. Anything you make with a bar chart could be, that's not true. Anything you make with a bar chart could be made with a pie chart. This is very true. Because you can make a bar of your favorite pies and a pie of your favorite bars. Bars and pie charts both display what? So those are the notes you want. You can make a bar of your favorite pies, a pie of your favorite bars. Bars and pie charts both display what types of variables? 1 type of this. Univariate categorical, univariate categorical, one categorical variable. So boom, right there, Zaid. Great job. Histograms and bar charts can display the same data. True or false? No, I can't spell either, Mark. Very, very false right here. What could we change this to? This is false because this is quantitative and this is categorical. So we would probably want something like box plots. And one good thing to do is if you have things on the test, you can look. And here's a box plot up here. And so you can see with the box plot, stem and leaves. Yeah, let's do a stem and leaf to end this section. We haven't interpreted a stem and leaf. So this is now true right here. We changed it to a true statement. Let's go grab a stem and leaf. Oof. Oh, we need to do a random sample because this is too big. Stem and leaves are not good for very large amounts of data. If you make a stem and leaf with a large amount of data, it looks like this. Don't make stem and leaves with large amounts of data. What does this represent up here? Look down here and read the thing. I don't like stem and leaves either that much. But it allows you to see the numbers in a quantitative distribution. So what does that represent right there? Does that person have 3 pets, or how many pets does this have? Yep, I'll post this later. So does that person have 3 pets? They have 33. So this is the stem of it, which is just letting us see right here. These are people who have between 10 to 11 pets, 12 to 13, 14 to 15, 16 to 17, 18 to 19. Here's where the 20 starts, the 30 starts, and it's the same data. Do you see this large gap right here? That large gap is the gap right here. Do you see this gap right here? Do you see over here? Do you see this gap I'm pointing at? That's the gap. It's the same data. You're viewing the same thing. That's why you don't need this. No one needs this. We don't got time for that. So with this right here, you can see there are 2 people who what? Over here, there are 2 people who what right here? There are 2 people, if you're reading this right here, there are 2 people who what? How would you explain what this means? There are 2 people who what? Have 8 pets. Madeline, you're exactly right there. There's 2 people who have 8 pets. There is what right here? There is that. Wait, I thought there's 3 people who have 8 pets. These people have 8 pets. What's the deal with that person? So these 2 people have 8 pets. This person here has 18 pets. Does it make sense how to read this? Like, these are the people who have 6 pets, and that's how many of them are. Like, each one of these represents a person with 6 pets. There are 3 people with 7 pets, 2 people with 8 pets, 1 person with 9 pets, 1 person with 10 pets. You have to connect the numbers using the key because the key tells you how to read this. So make sure you look at the key. That's probably one of the biggest hints I can give on the stem and leaf. If we do this for the high school GPA, wow, we're going to have lots of fun with this one. We'll see a pretty much crazy. Oh, look, not so bad. Does anyone see themselves on here? I am probably, no joking, probably this 8 right here. What was Brian's high school GPA? Not joking. I don't love back-to-back stem and leaves. We rarely to ever have one on there. Can't promise it won't be on there, but probably won't. I'm going for more low-hanging fruit. Brian probably had a 2.8 GPA, probably about in high school. More like this in college and this in grad school. Still, never got too awesome. This is pretty crazy here, right? So people understand what they're seeing, and you can also see the modality of it, but you're just seeing the numbers. Stem and leaves are just like histograms, but you can see the numbers for all the observations. And you don't want to make them with lots of data, then they look crazy. I think that's got it for this section. So hopefully, let's take a look at the review sheet again. Skew outliers, calculate the median by hand, calculate the mean by hand, interpret all these values right here. We didn't do tons of interpretation, but I mean, for 30 minutes, this is about as focused a review as you can get right here. Man, we're crushing it, everyone. Keep your energy going strong right here. We're going to hop into that next topic. Chapter 3 coming right up. 30 minutes per chapter. Strong review right here. Keep your brain going. We got this. The blanks in the stem and leaf just represent there's no data there. It's just like a gap in the histogram. Good questions, Zaid, right there. So if you see a blank area where it has like 3 but nothing on the other side of it, it's just for whatever span of data there was no observations. So no one had a score in that range. Well, we have to compute the mean and median from only a graph. Not from only a graph, we'd have to give you the data. We'd have to give you the data. You might have to read jump output. That's why I've looked at some jump output. Tara, let's go. You got this. I think I knew a Tara Love and Ashley Love in high school. Sounds like familiar names. Names are not identifiers, they repeat. I see that name and I'm like, I've seen that name before. So, long time ago, in a galaxy far, far away. Relationships between categorical variables. Oh, we got this. We're talking about some what's. Let's go check it out. Here we go with some relationships between... Can't think of my thing. Here we go. Let's check it out. Relationships between categorical variables. Chapter 3. It's not a useful chapter. Chapter 3. Relationships. There we go. New keyboard. Who does? Okay. On the exam, we'll be allowed to use our own calculator. You can use your own calculator. Yep. TI calculators are great, but not needed. They can help a lot, but not needed. I have students who ace the exam with TIs, and I have students who fail the exam with TIs. Helps to have a good calculator, but won't save you. So when we analyze two categorical variables, what kind of graphics can we use? No notes. No notes. Yeah, I'm definitely, Ashley. There's definitely been some questions on here like your exam. Because I know what's on the exam. What kind of graphics can we use? TI-84 is good. Yep. We could use side-by-side pie charts. I'm going to put that down here. Technically, yes. And stacked. Not a big fan of those. Those are the ring charts of this chapter. Mosaic plots. Great job, Zaid, right there. Mosaic plots. And we go right here. And also, what is a mosaic plots? Pivots? Yeah, great answer, Ashley. Pivot, yep. Evil ring charts. I don't know. What goes with a mosaic plot? Who's a mosaic plot's best friend? They're hanging down at Bar Knoxville. Is that place? Yacht Club. So they're hanging down at the Yacht Club. And who is the mosaic plot's best friend? Contingency tables. And think about what a contingency table says. It's going to show one variable contingent on another variable. So a contingency table is like a frequency table, but with two variables. So you have one variable contingent on another. And I always like doing our own examples for this. And let's go take a look at some data right here. Now, I truly mean this. Let's say right here, attend review. Did you attend this review tonight? And I'm going to collect real data from students on this, but we're going to make our own real data here. Attending the review is a what question? Attending the review is a what question? Attending the review is a what question? Attending the review is categorical. Great answers in the chat, 20 points. It is a categorical question. Did you make an A or did you not make an A is a categorical question too. Now, what we're going to get right here is we're going to get the students who attended the review and made an A, and the students who did not attend the review and did not make an A, or did attend the review and did not make an A, the students who did not attend the review and made an A, and the students who did not attend the review and did not make an A. Okay, let's go look at this. We're going to go here to analyze and fit Y by X because this is a what display. Everything we're talking about here when we talk about mosaic plots and contingency tables has an X and a Y because it's a what display. Mosaic plots and contingency tables, like these are the key concepts where you need to be like, you're like, well, yeah, mosaic plot and contingency table have an X and a Y because they're a what display. Is it also, kind of. Well, this is what we want to understand. We want to understand how the impact of the review, which would be a parameter of interest. Great job, Zaid, right there. It's bivariate. Yep. Oh, I clicked way too quickly. So here we are. We're going to look at, does attending the review explain why someone makes an A? Anytime I read this, I always say, does this one explain why this happened? And we're going to put here the frequency of the observations, and let's take a look. Do you see anything? Do you see anything? Do you see what I see? Look at this graph. What do you notice? What do you notice? Your thoughts. Ashley's right there. People who attended the review were more likely to make an A. Most students who attend the review made an A, but check this out. Most students who did not attend the review also made an A, because of the students who did not attend the review, who knows how to find out this right here? Who could find the probability of not attending the review? And I'll show you the table below. Let's use this table. I'm going to make the graphic a little bit nicer. So let's use, all right, we're going to make changes first. Show me the mathematics. Show me the mathematics for, and we'll take a screenshot. We'll bring it over here to our Word doc so we can draw on and stuff. Okay, got it. Show me the mathematics for the probability of not attending the review and making an A. Find me the probability of somebody not attending the review and making an A, which I actually have highlighted right now. Find me the probability of, and then show me how you found it. 90 minutes to take it, 90 minutes. Benjamin, great job right there. And Marjorie, also great job. Yep. So you would look at only the students, not now. Don't want to save yet. Only students who did not attend the review and the probability of making an A. So there it is right there. What is the probability? Ooh, this is a tough one. I can't do this one in my head. What is the probability of making an A for all students? What was the probability of making an A? Show the mathematics right here for probability of making an A. So find me the probability of making an A. What is the probability of making an A? Everyone's, yeah. And then 2 decimals are, yep. Great job right there, Ashley. And yep, everyone's finding it. It's going to be this right here and this. Now, who remembers the name of this? Frankie, good to see you here. So good to see everybody. Who remembers the name of this? This right here is in the margins. What is that right there? That's the probability a student makes an A. And so what is the name of that? Because it's in the margins. There's 2 of these. There's 2 margins, making them the 2 Chloe's got right there, the marginal distribution or marginal display. Marginal display is good. I think they call it that we call it marginal distribution. So the marginal distribution right there. Jasmine, excellent work, everybody. Marginal distribution. So now, what about this? This is not in the margins. This is given somebody did not attend the review. Zaid's on the right track here. So this, Brian's setting a what here? He's saying, what's the probability for someone who did not attend the review making an A? Jen's got it right here. This is a conditional distribution. Like the same stats as like the same stats practice. We do a lot of this right here. And then this is basically what you do in organic chem, because then you can find your observed minus expected squared over expected chi-squared test of independence, Marjorie, which you probably did in organic chem, classic chi-squared test, which is our last chapter of this whole class. So this right here is a conditional distribution. We're setting a condition right here to say, given someone did not attend the review. Now, how do you know if there's a relationship right here? The further the discrepancy. What do I mean by discrepancy? The difference in the what displays. Hint, here's one of these displays. So this is one of the displays, and here's the other display. The discrepancy is the differences in the whats, which we could also compare it to the marginal display over here. But the discrepancies are the differences in the whats. Because this is given someone did not attend the review, given someone did attend the review. Both of these are what displays. So this discrepancy right here is the difference in the what displays. Kind of. Well, this is for only people who did not go to the reviews, which is this one right here. And then this other one here is for only people who went to the review. Difference in the conditional displays. So this is the condition someone did not go to the review. This is the condition someone did go to the review. And these are the differences in their percentages. Who here, I will throw 200 points if anyone can calculate this discrepancy value right here. Who can tell me quantitatively how much is this value right here? I promise it's not as hard as you think. You've already got one of the numbers. Who here can tell me this difference right here? Who knows it? So think. Here, put our little thinking music on. We got this. You can do this. I know you can do this. So the difference in the conditional displays will tell you if there is something going on here. The bigger the difference in the conditional displays, the more stronger of an association there is. Like, oh, this looks like a pretty strong association. This is about as tough of a question I can make, Jasmine. Everyone's saying about 0.2, maybe. It might be about 0.2. Let's find out mathematically. You ready right here? Mathematically, what percent of students did not attend the review and made an A? What percent of students did not attend the review and made an A? We're breaking it apart into smaller questions. This is as tough as I can make this question. And it's teaching the concepts of, we're looking at difference between the conditional displays of students who did not attend the review and made an A. Ashley, great job right there. I'm highlighting it up there. The answer is highlighted currently on the screen on how to get it. So Ashley just found this one. Really? I'm red, purple colorblind. Okay, and then we need to find the other one. Who knows what percent of students who attended the review made an A? What percent of students who attended the review made an A? And it's highlighted for you right there. So this is only students who attended the review. It's only these students here. That's what we're seeing right here. Only these students right here. And so that's 80. Microsoft Word, you're not cool. Really, you're not cool. Trolling me. So now the difference between them would just be subtracting the two. And then you could say 24.4%. Excellent job, Frankie, right there. Excellent work. 100 points, everybody. Did I say 200? I think I owe you guys another 100 points. You guys, gals, everyone, pals. So excellent work. Is this making a little more sense right here on what these conditional displays are and what the marginal displays are and what we're seeing right here? Now, which group on the bottom here is a little bit bigger? The yes or the no group? You can kind of tell if I do this. A little bit easier to see now. The yes or the no group is a little bit bigger. Which one's a little bit bigger? The yes group. And Brian is displaying down here the what display on the not conditional. On the mosaic plot, Brian is showing you currently the what display. Brian is currently showing you the what display on the mosaic plot. He's currently showing you on the mosaic plot. I'm showing over there too. Yep, Griffin, we did. Yep. And it's the marginal display because it's in the margin of it. The other marginal display is over here as it is over here. It's turned sideways. So tell me, what percent of students did attend the review? What percent of students did attend the review? So show the mathematics and tell me what percent of students did attend the review, which is slightly more than those who did not attend the review. And this would be a marginal display because it's in the margins of the table. Everyone's doing the math right there off. Oh no, I got to solve it, right? 100 over 190. Would you specify the marginal? You can flip them. Great answer right there, Ashley. It doesn't matter. You can flip them. It doesn't matter which is in which spot. You can flip them. On the test, we usually show the graphic, but that's a great question. The relationship between X and Y is the same relationship between Y and X. I did a decimal place incorrectly, it looks like. I'm just going by what answers people say. Word's going to troll me. Troll on Word. Do what you got to do. Brian can't math. Ashley, great questions. Thank you so much. Everyone, thank you again for being here. Once again, I know we're doing lots of review right here, and I'm trying to think of more things we can ask on this. Let me go look. Go look and think of some things to ask right here. Okay, let me find some things to ask. Be putting your questions in the chat. Chapter 3. Oh, yeah. If I could give you any advice for this, it's Canvas content. If I can give you any advice for chapter 3, Canvas content. If I can give you any advice, is that Canvas content. Let's do a few more. You ready? Let's rapid fire. You know what that means. It's time for some lightning round, everybody. I don't know where everything's at. What's going on right here?
It's time to do some Canvas content type questions. Oh, we'll do some complicated Z-score stuff coming up here soon. But right now, can you do these questions? Let's find out. Here we go.
Okay, you ready, everyone? Heck yeah, Puppet Shark, let's do it. So we're going to do some Canvas content type questions. Let's see how quick we can rapid fire these. So we're still doing some chapter 3 right now. Let's go grab some output. We're going to need as much output as we can get. And let's go over here to analyze and go to fit y by x. Let's go to okay, someone pick a Q variable. Not the z-scores, not the z-scores, not the b's. Let's go here and look at number 9. You can, yeah, let's do number 9. Let's see if people broke a bone. Dependent upon, ooh, major's a crazy one. Major would work, but there's so many levels. Let's look at people's relationship and see if they've broken a bone. Oh, a little bit interesting stuff going on here. Okay, so let's put the contingency table down. And let's go, let's take a look at this. Okay, we got it. And wow, big contingency table. Okay, let's go take a picture of it and bring it over here and ask some questions. I'm going to rapid fire questions. See how many of these you can get. Here we go with the rapid fire questions. What is the probability of dating multiple people and breaking a bone? We got some crazy questions. What is the probability of dating multiple people and breaking a bone? What's the probability for multiple people for dating that they broke a bone? Great job. It's going to be 20 divided by 40. So there it is right there. The probability for dating multiple people. What is the probability given someone has broken a bone? What is the probability they are widowed? Given someone has broken a bone, what is the probability they are widowed? Given someone has broken a bone, what is the probability they are widowed? Given someone has broken a bone, what's the probability they're widowed? 0 out of 375. Now, whenever I say given, or if we say like for the, like for dating multiple people, you have to go in here and only look at this. So you have to say for the people who have broken a bone, given someone who has broken a bone. This is a what display again? What display are we looking at again right here? We'll do another version of this in a second. We're looking at the what display right here. Conditional. Mackenzie, great job right there, 20 points. That's a conditional display right there. And so, let's switch from the conditional display to a what right here. Now we're doing a marginal display. So what's the probability of breaking a bone? I've got a guesstimate in my head. I think it's about, I would say this is a marginal display. It is a marginal display. It's about 47%. You're going to have to tell me. That is the answer, yep. Great job, Kelsey, right there. Good practice. Oh, wrong answer. Is it 40? I think it's 46.5. 46.5 sounds right. I was doing it in my head. I was trying to think through it. 46.5 sounds, I was thinking it was 47. I was trying to brain solve it. Didn't work. So about 47%, 46.5%. He'll switch up we're going to switch up the plot right here. Let's go to a new plot. Now notice whenever I'm making these, we're not going to use this one. I'm going to go here to analyze fit y by x and choose, that's our fake data. I'm going to choose a variable where both of the variables are categorical, such as like we're going to go right here and pick your family economic level. And can that be explained by, do you purchase, nah. Like, I'm trying to think. Yeah, let's look at distance from campus. This is going to be a big table. Okay, so now we're seeing if family economic level can be explained by your distance from campus. That's a big table. We'll use it, though. This is about as complicated as I can get it because we have a whole bunch going on the screen right here. Okay, let's go take a look at this. and drop it in here. Lot going on the screen. Okay. What is the probability of going to UT and being upper class? Caroline, everyone chat's killing me. What is the probability of being an upper class and going to UT? What is the probability of being upper class and going to UT? It might be, Ashley, you might be right. That's still good enough to see, right? You might be right. 57 over 806. That is a marginal display. That it's in the margins. What's the probability of being... I'm trying to think where the biggest differences are. Given someone lives on campus, what's the probability they're in upper class? Given someone lives on campus, what's the probability they're in upper class? So given someone lives on... Gosh, everyone's quick. You got this down. Double check your numbers and you're good. That's got it right there. 4 people in middle class... What percent live on campus? For people in middle class, what percent live on campus? Another conditional display right here. For people in middle class, what percent live on campus? I think you got this down. Double check your numbers. Read the questions carefully. It's probably my best advice on this. Not a lot of questions people are asking right now, but you're figuring it out. And then just think about the ways we can ask questions from this with a marginal display, with a conditional display. And just think, is the question asking you a marginal where you only look at the margins because it's not talking about two variables, like the bivariate combination? Or if it is asking about a bivariate combination, are you looking at like within this variable or within this variable? This chapter doesn't feel so bad, right? We're about to get to the big ones here. We're about to get to the big chapters. So I tell you what, let's start another chapter because I think we're good on this. There's not, what else is there to cover on this? Be able to calculate a relative frequency, marginal distribution, conditional distribution, interpreting segmented bars. We don't really do a lot of that. Is jump something? You won't have to use jump on the test. You just have to know how to read the output. Recognize independence or dependence. Okay, let's look at this. So we made our graphic right here. Here was our original graphic, right? Remember this graphic right here we made just a little while ago? And let's change it now. How would you feel about this review if, let me go here. Good. How would you feel about this review if the numbers looked something like this? How would you feel about this review if the numbers looked like this? Good or bad? I'll have to take a look. 1 second, Savannah. You got it. I'd actually feel like, why am I here? I'd feel bad. Because did you attend the review? Did you make an A? It's like you're wasting your time, right? Don't worry. I don't think you're wasting your time. But I'd feel bad. Like this is a bad idea. Because the people who attended the review were super likely to not make an A versus those who didn't attend the review. That's kind of weird, right? But how would you feel about the review if you saw something like this right here? How would you feel about the review now? So these are the people who attended the review. These are the people who did not attend the review. Well, everyone here. Now, I get, And exactly, Mohammed's pointing out, great job, Mohammed, right there. It's not dependent. These are independent. And the bigger the discrepancy, which is what we were pointing out earlier, the bigger the discrepancy is going to point to, well, now take a look. There's a discrepancy. I can make the discrepancy bigger because now when you look at this, now people who go to the review because of the discrepancy right here are more likely to make an A, where 94% of these people, the people who went to the review, made an A. Only from the people who did not go to the review, 61% of the people who did not go to the review made an A. So the bigger the discrepancy right here, which just means a difference between the two conditional distributions, which we could calculate down here from the tables, would tell us information on whether or not the review has a relationship or there is dependency on your making an A dependent on the review. So good stuff right there, and that pretty much covers everything. Do remember this is just one review, so it's like a little bit of a Cliff Notes thing, as I always say about my reviews. But we're on to chapter 4. Look at this. We only have one more page of stuff. Might get done a little bit early. Maybe I'll eat some dinner. I don't know. We'll find out. Let's go here to the main screen and get ready for some chapter 4. How are people doing right now? Let me put on this music. I'm really proud right now. How many people do we have watching? I shouldn't look. We still have over 100. That makes me smile. Optional review night. I had a milkshake of sorts. Almond milk, peaches, protein powder, good stuff. Yeah, got a lot of sun today, it looks like. Played some Pokemon, got some shiny Pokemon. Good day, Jasmine's doing great. Good to hear that, Jasmine. Feeling pretty solid. I can't speak. LSN? Don't know what that is. I got my husband cooking dinner. Kayla, that's the way to do it right there. We had like crepes for breakfast this morning. I got another test, so amazing. Awesome job here. Did you do your pulse system? I did. I did like 7, but I found out that I'm doing chin-ups because I'm going this way. So I gotta start going the other way. I gotta start doing more pull-ups that way. So, you know, I'm doing this way. I don't know. It's easier. Went to Dollywood for free today? That's awesome. Dollywood is awesome. Kahoot will be like an hour or so. It'll be like an hour. That's the healthiest milkshake I've ever heard of. Gotta try to eat a little bit healthy. I agree with Lauren right there. Almond milk greater than regular milk. I do agree. I started drinking almond milk, bought it a few times and didn't drink it. Enjoying a Corona. If you're of age, have at. Drink responsibly. That's always, you know. That's what I say. Well, everyone's having. What are the prizes? $100 in prizes. $50 first prize. $30 second prize. $20 third prize. Oat milk. I do think oat milk might be one of the ones I don't like. I'll have to try that. I'm almost 30. I'm almost 40. Regular milk equals sugar on sugar. That is true right there with lactose, right? Almond water. I agree because I'm lactose intolerant. Yep. A lot of people like the silk stuff right there. Oat milk, yeah. I'm drinking almond, right? Maybe I'll try some oat milk. Oat is better for the bees. Oh, yeah. Bees. We need to save the bees. A lot of issues. I mean, the bees are basically like, without bees, no humans. Wide grip pull-ups. Pull the elbows down and back. Oh, I need to do that there, Jack. No chin up, though. No chin up. Wide grip pull-up. Wide grip. Start working on that. Jack, I'll get you 10 wide grip pull-ups by the end of the semester. I'll try. Let's do this right here. Understanding and comparing distributions. Let's check this out. Macadamia milk? What is that? All sounds good. Oh, I'm not a fan of bees. We did save a bee out on the lake. Bees just want to do their thing. They're just chilling. And then they sometimes invade our space and we're not happy. Thank you, Jack. I appreciate that right there. So the first thing we need to do is know what the 5-number summary is. Let's go over here. Understanding and comparing distributions, chapter number 4. Getting our serious face on right here. Let's go over here. And thank you if you are in our class or not in our class. If you're just visiting today, we're glad to have you here. So shout outs. Who is visiting today? Who is on here who's not usually in our class? So let's throw you 100 points. Boom, right there. The IQ. This will be a little bit different. You're close right there, Ashley. Good to have you here, Jacob, Catherine, both Catherines here. Lena, good to have you here, and Kendall. Thank you so much for swinging by today. So, the 5-number summary, understanding, comparing distributions. Wrote the right thing right there. Okay, let's do this. The easiest way to do the 5-number summary is to draw 4 whats. The easiest way, and great job in the chat. The chat knows 5-number summary. The easiest way to remember the 5-number summary is to draw 4 whats. The easiest way to remember the 5-number summary is to draw 4 whats. 4 quarters. You are right, Kayla. Quarter 1, quarter 2, quarter 3, and quarter 4. Magic color change pen to the rescue for once. So here we are with 4 quarters. Now, once you draw your 4 quarters, I want you to go to between them and put lines between them. I'm going to ask you some really difficult questions here. You ready? What is the lowest number in the data set? So if you don't know the 5-number summary, really good practice. You can't write this on your sheet beforehand, but good practice. The lowest number is going to be the what value? The min. Great job. The highest value is going to be the what value? The highest value is going to be the what value? The highest value is going to be the what? The max. Now, the middle number is going to be the what value? Like if you're like 50% the way through the data, that's going to be the what value? If you're 50% through the data, that's going to be the what? It's going to be the median. keep wondering why color changes. I'm trying to figure it out. Never know. The world may never know. Now, this is where people get confused, but I want you to think about this. How much of the data have you added up to by this point? How much of the data have you added up? I know. So what do you think? You've added up one what? Just pick it up and you say, I picked up one what right now. I've picked up one what. And then we can call it this. I've picked up one what. I have picked up 1/4. Let's call it Q1. Well, what do you think we're going to call this all the way over here? Any crazy guesses right here what we're going to call this? Whoa.
Wow.
Oh my gosh. Q3. Never would have guessed that. Q3. Now, we do have another important concept right here, and it is this. This distance from Q1 to Q3 is known as the what? Like how far those numbers are away from each other. How far those numbers are away from each other. Great job, Catherine, Marima. Mary, excellent work. That's the IQR, which is the range of the interquarters, the interquartile range. It's just like the range, but doesn't cover the full data. So all it is big number minus small number. You know what? A lot of people wonder, what happens if I do Q1 minus Q3? Well, you'll get a negative number, but you still get the range. So the truth is, it doesn't matter. Really doesn't matter which way you subtract them. You do Q1 minus Q3, you're still going to get a range. Just make sure you remember it's positive. So it's just how far away are those numbers. The IQR is just a distance, making it a measure of spread. That's a little bit of a review right there, that the IQR, the interquarter range, is the range of the middle 50% compared to the range of the full data set, which is going to be the max minus the min, like how far apart are the biggest two numbers in the data set. Now, you're welcome, Mark. I realized we hadn't done it this whole review, so I was like, we need that right there. We need a little rock here. Who doesn't need the rock? Definitely me. I need the rock. So with this right here, we've got the 5-number summary. Let's take a look at another topic. Good stuff on 5-number. Interpret side-by-side box plots. Ooh, I know there's some test questions on this. Let's go make some side-by-side box plots. Here we go. Once again, I've seen the test. You haven't yet, but I know there's some side-by-side box plots. Let's go make some data. You will not be required to use jump on the test, but you will have to read jump output. Knowing how to read and understand. Now, box plots, side-by-side box plots, are a what display of data? Side-by-side box plots are a what display of data? Side-by-side box plots are a what display of data? Very important. I've seen the test in my dreams. Only in dreams. Bivariate, Megan. Great answer right there, Megan. You are correct. Side-by-side box plots are bivariate, and box plots are quantitative. So we have to put a quantitative variable here, like that makes it a box plot. So that's going to make box plots. And then we have to go here and we have to put something categorical on the bottom. Now we can make side-by-side box plots. It's right here. Let's go here. See, we get the 5-number summary. It's not usually how we display it. We could display it like this. Sure. Which group, males or females, has the greatest range? Which group, males or females, has the greatest range? Is it males? You are correct, I believe. Yes. Who wants to calculate the range for males? And it's probably, yeah, it's because that outlier. Yeah, you can see it visually. Make sure to cut. Ooh, I'm going to throw some 100 points. Should just look visually at it. So you are correct. Make sure to, we can see the range of males is this. Here's the visualization of the range of males. That's the range of males. Do not, it's not this. This is where outliers begin. This is the end. This is the whisker of it. This is where outliers begin. This is where outliers begin for females. But the range for males would go from the highest value down to the minimum. I think Jen's or Ashley's got it right there. It is 2.93. Let's see, right? The males one. The males range is what again? I see a lot of answers. Show the mathematics for the males range. Yes, is it 2. It is 2.93. Mackenzie, thank you so much. Mackenzie's double showing it right there. Mackenzie's mathematics is accurate. Make sure to look at Mackenzie's and Catherine and Maris and Haley's answers right there. The range for females is going to be right here, and the range for females is a little easier to calculate. The range for females is how much? Little easier to calculate the range for females. Little easier to calculate the range for females. The range for females will be 2.4. Which group has a bigger IQR, males or females? Which group has a bigger IQR, males or females? Which group has a bigger IQR, males or females? Well, I kind of pointed to the answer right here. So the bigger IQR is going to be males, 3.5 to 4. So the males have a bigger IQR. The males middle 50% ranges from 3.5 to 4.0. They give you some extra numbers here. This is not part of the 5-number summary. It's the 90th percentile. So we'll talk more about percentiles on chapter 5 coming up here very shortly. But this is the 90th percentile right here. Here's the 75th. Percentiles go... So what is the maximum? The maximum, because I don't want to tell you the answer, the maximum is the what percentile of the data. The maximum would technically be the what percentile, because you've gone through all the data. So the maximum would be the what percentile of the data, the 100th percentile. So up here is the 100th percentile, and down here would be the 0th percentile, the very bottom of the data. There's no data below it. 0 represents there's no data below this. 5 represents there's 100% of the data below it. I don't usually call it the 100th percentile, and a lot of times tests don't even tell you there's a 100th percentile. You're like in the 99.99th percentile. With this right here, let's think of another question. It's pretty good self-explanatory. Let's do a different graphic, but great job reviewing right there. Analyze, fit y by x. Let's pick a quantitative y variable, like how much time do people spend reading? And let's go here and say distance from campus. So which of these, you know what, I'm going to change it. I'm going to go to Graph Builder because we do make graphics to this. Let's go for family order and time spent reading. There we go. And then let's go to box plots right here. Okay, and then 2 seconds. 5-number summary. Got it. Good. Okay, which of these has the greatest range? So it's really a lot easier with the 5-number summary. I've done you a huge legalizing. Which of these has the 0th? Which of these has the greatest range? You are correct, Muhammad. I'm throwing 100 points because I actually had to pause. Muhammad was correct. I actually looked incorrectly at it and didn't see that outlier. So I threw some big points because if I had to answer off the top really quickly, I didn't even notice that one. But Muhammad's right. There's a range of 50 with this group. Watch out. You could easily go to your eyes looking at this. So what's one of the things we should do when we look at box plots right here? Always remember with range to look for what? I know, right, Kayla? I might have gotten this wrong if I had to do the question. I know how to do it. You just make mistakes. Look for those outliers. Don't forget to look at outliers. They're part of the range. Very easy to make mistakes, and hence why I'm picking questions like this. I'll make mistakes. Zaid, you are correct. Max minus min. Max minus min. Which of these has the biggest IQR? And you can actually see this one visually. So go ahead and figure out the biggest IQR right here, and then let's point out where the IQRs are at. The IQR is the box of the box plot. So you could actually estimate an IQR by doing something like this, like, hey, that looks to be about 6. Oh, it is 6. 10 minus 4. So the biggest IQR is where? The biggest IQR is where? The biggest IQR is middle. Who can calculate it? So it is middle, unless I'm trying to run all the numbers. Middle has the biggest IQR. And middle's IQR is 8. 12 minus 4. Yes, I can't wait to see the grades on this test. You're doing some great practice right here. Now, chapter 5 is going to be a tough one. Don't leave before some chapter 5. People were getting burnt out. But hopefully this review has been a big help right here in practicing concepts like we're looking at side-by-side box plots right here. And let's talk about some side-by-side histograms. These are easier chapters. Chapter 4 is a bit easier. Not a lot of concepts here. When we have stacked histograms, it's coming up here soon. Yep, chapter 6 on test. Yep. When we have stacked histograms, when we do stacked histograms, they are bivariate quantitative. So we could look at family order. That's correct, right? Yeah. And then we could look at people's high school GPA. And we can make here stacked histograms. But what do we need with stacked histograms? Whenever we do stacked histograms, we would need what for stacked histograms? What needs to be the same for all stacked histograms? We need to give them all the same what? stacked histograms should all have the same X scale, the same horizontal scale. This is what I'm doing right here by clicking uniform scaling. I'm giving them all the same uniform scale so we could compare them all. Now it's a little hard to see them. Here, let's make it smaller. So we can eventually maybe see them all at once. Maybe, who knows? So we're eventually going to see all these. Let me make it smaller here, and you can start to see. Not big differences, but they're all on the same sort of playing field. Numbers are very, very tiny right now, but they all have the same X scale. Does that make sense? The same number line down here, Kayla, good question. 20 points, Kayla. Thank you for the clarification right there. But they have the same, like I could change this right here to be something like 0 to 100. So there's going to be one of these now that has a totally different horizontal scale. So now they all have the same horizontal scale. They're all on the same playing field, except for whatever that says, only child. Yeah, sure. I'm sorry, only children. So I personally like an only child. I don't know. My fiance. So, yep. So that's what we mean right there. Great question, Kayla, to clarify that this right here is going to be the same horizontal scale was used to create all three graphics except for one. And so that puts it all on the same playing field so we can compare them. So this one right here does not have the same horizontal scale, and that just is not a good idea. That's bad. Bad idea, good ideas with the other ones. And so that's what we mean by same horizontal scale. Let's bring back our font size. Bring back normal font size. So you're welcome. Great clarification question. That's if no one asks questions, then what's the point? 20 more points, Kayla, right there. Comparing distributions using histograms, identifying and interpreting box plot components. Let's break down a box plot. Please ask anything you're wondering about. I'm just doing everything I can do, like going through all the knowledge here. Ooh, let's talk about that just briefly because we probably haven't mentioned that enough. It is in the review a little bit. Let's start with this right here. A time plot. We so rarely ask any question on the test on this. So I know, right? I don't even know if that note is in the chapter anymore. I might ask Terry even. Because I swear we don't even have the notes on that. What is a time plot? It is in the review tonight also. What is a time plot? Time plots are special case scatter plots. Time plots show time on the y-axis, on the x-axis, and a quantitative variable on the y-axis. So with this right here, are you ready? I'm literally going to give you you ready for this? Teaching to the test moment. So scatter plots, which we'll see on chapter 6, show quantitative relationships. Does that make sense what a scatter plot shows? Scatter plots show quantitative relationships. Does that make sense right there? So a scatter plot could look something like this. Here's what a scatter plot looks like. It's going to show height, which is quantitative, and it's going to show weight. And what do you notice about height and weight right here? What relationship do you see between height and weight? You see a positive relationship that is someone's taller, they generally weigh more. Does that make sense? Taller people generally weigh more. That's a scatter plot. Strong linear, exactly. That's where we're getting into chapter 6. And then what is a scatter plot? I mean, a time plot. A time plot is a scatter plot, but let's say it's price of houses over year. So let's say here, house, and then price, house price. And the housing market, sure. So why is this a time plot? Why right here is this one a time plot and not a scatter plot? Why is this one right here a time plot and not a scatter plot? So why is this one a time plot? So this one over here is a time plot. And this one over here is a scatter plot. Remember, time plots are just special case scatter plots. And then because on the x-axis right here, The time variable right here makes it a time plot. Does that make sense? So don't worry, it's not a huge concept. Not big stuff right here. Time plots are special case scatter plots where the x-axis has time on it. So a time plot is just like a scatter plot, which is two quantitative variables. And so is this making sense? How little is the panic going down right now? Is panic subsiding right here? And the trend we would notice is we just look at it and see if it's like linear or if it's going down or up. And you just look at it. So noticing a trend in a time plot is just looking at this and saying, oh, housing prices have been increasing over recent years. So the average price of a house has been increasing over recent years. So in the test, we discussed the time for a time plot. The x-axis is time compared to, this is basically, scatter plots will be coming up here on chapter 6. So more in-depth talk on chapter 6 and also chapter 7, which is not on this test, has scatter plots, and chapter 8. So scatter plots will be important for this test for chapter 6. In chapter 7 and 8 for the following test, which will be on regression. Less panic. That's what we like to hear, Catherine, right there. It's such a small little thing. I think we covered a little bit more in chapter 6. It's like the rectangle and squares, all time plots, scatter plots, but it's Savannah. Boom. Exactly. So all time plots are scatter plots, but not all scatter plots are time plots. Explain why not all scatter plots are time plots, because look at this right here. Why are not all scatter plots time plots? That's exactly right, Savannah, earning those big points. So why are not all scatter plots time plots? Because not every single scatter plot on the x-axis will have a what? So you're exactly right. Because not all scatter plots have time on the x-axis. Ashley points right there. That's some Ashley points right there, 20 points right there. Not all have a time variable on the x-axis. And that's what makes it a time plot. It's like a subtype. It's a special kind. It's like all things are sandwiches. Like a taco is a sandwich. Our crepes this morning were a sandwich. My bottle of water is a sandwich. It's like, yeah, I don't know. I've done lost my mind here, everybody. So, because exactly, great work right there, Hunter. Let's look at that sheet again and see what we have right here. So, oh, we saw one more, right? Identifying, interpreting box plot components. Okay. So box plots display what kind of variable again? This is a little bit of a review right here. Box plots display what kind of variables? Who knows what kind of variables singular box plot, one box plot displays? I'm going to go make one over here. While you tell me what kind of variables box plots display. I'm going to do a box plot, quantitative. And if I'm doing a box plot, I'm doing univariate quantitative. So you can do bivariate. And let me show you right here. Anytime you are doing a box plot, it is quantitative. Like a box plot is quantitative. And we'll throw in the 5-number summary. I'll write it on it afterwards. Ooh, I'll tell you why I don't like this, because the median is on top of something. So I'm going to use this one. Can I replace it? Start over. And now let's do this one. Much better. Okay. So right here, you can see a quantitative variable being displayed in a box plot. Great job, univariate quantitative. That means one quantitative variable. Now you can do what's called side-by-side box plots. And so these are still box plots, but does everyone see why it's called side-by-side box plots? And then we're splitting it apart on a what type of variable. So this is now side-by-side box plots, which is a bivariate display. It's not just one box plot, it's two box plots, and it is now a what display. And the second variable you can see is a what kind of variable. Brianna, great answer right there. 20 points, Brianna. It is bivariate, and we're splitting by categorical. Exactly, Ashley. So this is still a quantitative Y, like the box plot component of it is still quantitative. You wouldn't say, well, box plots are categorical then. It's just you're making two box plots. So you have two quantitative distributions, one for people who are not born in Tennessee, their high school GPA, and one for people who are born in Tennessee. So still two box plots, still quantitative, just breaking it apart. Let's go over here and think about this. We'll use this one. Why not? It's a pretty good graphic. It's a good boy. And so let's go grab this graphic right here. And let's take it. Not part of graphic right here. Ooh, we're about to some chapter 5. Don't go. Chapter 5's coming up. Okay. So the box of the box plot shows what? The box of the box plot shows what? Which looks to be about 0.5. You can estimate from that. Great job, Catherine and Aaron right there. The box of the box plot shows what? This is knowledge that we just like, boom. Jasmine's got it right there. Jasmine's got that knowledge. It's going to show the IQR, which is Q3 minus Q1, which stands for the 75th percentile of the data. Like 75% of students have below a 4.0, at or below a 4.0. 25% of students have at or below a 3.5. How do I know that? Because the bottom of the box plot is the 25th Q1, 1/4, and the top of the box plot is the 75th Q3, 3/4. Always think about 3/4 right there. Oh, Catherine, we got this. 20 points, Catherine. Don't worry, we got this. There's my points. So here we go with the IQR. Now we go here and we got to ask very carefully. A lot of people get this wrong. What is this? Do not be confused by it. What is that? It is 50% correct, but that would be where the median is at, Kayla. You are correct. The median is where 50% of the data is below that. 75% of the data is below here. 25% of the data is below here. And I'll go back and do the median in a second. Catherine is right there. That is where the outliers start. Now, it might be near the lower fence. Ooh, we got a good concept we haven't said yet. This is outliers start here. So the lower fence, that is the end of the whisker, but maybe not the lower fence. Here's how to find the lower fence. Q1 minus 1.5 IQRs. Put on your thinking music. These are the more difficult questions. And for 100 points, who knows where the lower fence is? Drink the last of my water. See if you can mathematically solve where the lower fence is. Just like spill water on myself. Who knows where the lower fence is? No more water. Benjamin right there got it. Benjamin, excellent work. That is correct. Great job. It has to be somewhere in this range. Like, it has to be somewhere. It can't be as low as those outliers, though. So the answer for this, if people are wondering how we got it, is we can see here visually that this is at 3.5. Then we subtract from it 1.5, and how much is the IQR worth? So how much is the IQR worth? The IQR is how much? For those who are like, I have no idea how they got this. 0.5, exactly. And so this is going to equal 3.5 minus 0.75 equals 2.75. The upper fence, who can solve where the upper fence is at? Who knows where the upper fence is at? It's a symmetric difference away. Solve for the upper fence if you can beat me to it. See if you can do that. Did it give you the 100 points? Maybe I'll give you another 100 points. You have to suffer through my bad handwriting or... Oh, people are getting it. It's like something's wrong there. I was looking at that and I was like, that's not right. And there we go. So that's where the upper and lower fence are at. Sorry, Kayla, I made a mathematical error. I had a minus in there. Remember, it is above Q3. So sorry if I took people to... I know, right? I was so sorry, Troop T right there also. I put a minus in there. It should be adding on because you are going above Q3. So it needs to be above Q3. So this is the maximum value. This is the minimum value. The bottom of the whiskers can be... Brian can't math. Brian can never math. They didn't teach me how to math in school. And this right here is the median. If you understood everything we did right here, you're really set to go on box plots. Awesome job, welcome, Mohammed. Great work. Let's do this. Everyone, get that hacker man mindset going. You know what that song means. It's time for some chapter 5. Feeling good? Well, Brian's gonna feel good if his fantasy team's winning. How's Brian's fantasy team doing right now? Dak Prescott, you doing all right? Dak, oh my gosh, Dak Prescott's got 6 points. No! Dak Prescott, throw some touchdowns quick. The Tampa Bay one, I'm good about that. Cardinals did horrible. Oh my gosh. Well, I'm set to get 85 points. One of the lowest scores in my league. What happened to Dak Prescott? How's my other team doing? Oh, I'm winning in my other league. But I might not totally win. Ooh, other guy's going to get more points than me, it says. Chapter 5. Oh, Troop T, thank you so much. I'm glad I said it correctly. Hopefully I said it correctly this time. If I ever mispronounced your name, please tell me. I always want to pronounce everyone's names correctly. And it's probably luck because I'm so bad at pronouncing things that like most things people will pronounce incorrectly, I'll pronounce correctly, I guess, because I'm just really bad at stuff. So I somehow get the things people get wrong right. Good luck right there. We'll explain the difference between the whiskers and the fence one more time. So the whisker is just how far, like the literal end of it is the whisker, but the fence is a mathematical calculation. I'll turn the music down a little bit right here. So Brianna, the fence is a mathematical calculation that is always what? So the fence is always what? Who can explain right here? The fence is always what? Go to Q1, and the fence is always what to Q1? The fence, which is where outliers begin, is always what? And I've got a good speedrun video over this. But the fence is always what? Yeah. I've got them. Let me write. Yep. So here, I'll put them in the chat right here. Q3 plus... Oh, it's not Q3. Q3 plus 1.5 IQR. So the fence, which is a mathematical calculation of where outliers begin, is always 1.5 IQRs above Q3 and always 1.5 IQRs below Q1. That's just a mathematical calculation of where outliers begin. That's just mathematics. And so the fence you won't see because we don't draw the fences, like we remove them afterwards. But then the whiskers either go to where the furthest point is, or a whisker could be a what or what. Finish Brian's sense right here. A whisker could be a what or what for your data. Like where the whisker goes to could be the what or what for your data. Because you can get some weird looking box plots. I'll show you a weird looking box plot. I'll show the background right here. The whiskers go to the max and the min, or they'll be the most extreme point in the data set that's not a max or min. So the whiskers go to where the max and the min go. And so this right here, no joke, ready for it? That's a box plot. This is a box plot. All the data for this, I'll disappear. All the data is 5, 5, 5s, and 7s. This is a box plot. So up here at the top, and look at it, the maximum value in this data set is 7, and the 75th percentile is at 7. The median is at 5, the 25th percentile is at 5, and the minimum is at 5. If we change around the data here a little bit, I think it will change with it. Let's try it. If we put an 8 in here, is it going to change it? There we go. Now it has a whisker. But if I put up here something like 9, oh, it goes even further out. But if I put 12, now 12 goes beyond. So remember, the whisker will go out as far as there are points, but if there's no data, the whisker won't extend. So the bottom whisker is, no. So this instance is just a rare instance where the bottom whisker is where Q1 is. It's just that they're on top of each other. There's so many 5s. I could make it so a bottom whisker appears right here because now there is data below 5. So does that make sense right there? The bottom whisker won't always be where Q1 is at. Sometimes you get weird looking box plots where they overlap. Right now, the median is also overlapping on the 25th percentile. The median is right here. It's just overlapping. So there's weird looking box plots, but the whisker shows you the data that is farthest away, that is not an outlier. Let me ask you this question right here. And so let's ask one more question on this. You ready? Where is the bottom fence? Who knows where the bottom fence is? Who knows where the bottom fence is for this data? So look here. Here's the IQR. So where is the bottom fence? If you know how to find where the bottom fence is, where is the bottom fence? If you know how to find this, you know how to use the mathematics for this, and you understand the concepts very well. Where is the bottom fence? So what is the formula again? I'm going to put it in the chat. So watch the chat. Q1 minus 1.5 IQRs. So the formula, and so Kelsey's doing it right there. Kayla's got it. So watch the chat and think about this. So the IQR is 2. Did you see that? That is 2. And then you'll go to Q1, which is at 5. And then you go down 1.5 IQRs. So it's 5 minus 1.5 times 2. And that's where the lower fence is. You don't see the lower fence. Lower fence isn't on here. It doesn't show you it. But the lower fence would be here at 2, which means theoretically, If I were to go here and take one of these points and make it 2, it would not be an outlier. But if I made it 1.999, watch this right here. Now it's outside the lower fence. Guess what? It's an outlier. Does that make sense that there's an invisible fence here that you can't see? And this is what the fences are, where at 2, it's on the fence and thus not an outlier. But at 1.99, it's going to be an outlier. Now, we could have a point that goes up to it. And now we have a point that's at the lower fence and a point that's beyond the lower fence. Now the lowest point right here is 4, and then there's a gap between 4 and 1.99. But if 1.99 were to be 2, it'd be on the lower fence, and thus we don't even see the gap anymore because the data goes through this. Does that make more sense to everybody right there, talking about how it works? The fence is something you don't see. You don't see it. It's a mathematical calculation of where the whisker can extend to. Like the whisker will go up to the fence if there is data there. So if there is data, the whisker will extend through it. So I did that in the background window. But I hope that makes a little more sense. And I do have a speedrun video going over drawing it that could help out. The 1.5 number is super important for the test. Like I'm just saying the whole thing right here. But yeah, we got 2 more big chapters. I'll tell you what, the pivot chapters we might not cover tonight because I'm going to try to get a little break in here between this and doing the Kahoot. So pivot, please check out the review playlist for pivot. Most important things is making your pivots and being able to read them and just understanding how to look at them. You know what this is. You know what this means, everybody. It's time. Everyone's favorite chapter. Can I do it? Oh, man. I used to have cool effects that played lightning in the background. Puppet Shark, we got that lightning effect ready? Puppet Shark? No, we don't got the lightning effect anymore. We got to reset that up. Chapter 5, let's do this. No lightning effect tonight. Okay, here we go. Chapter 5, everybody. Everyone's favorite chapter, Chapter 5. I do love some Chapter 5. Really? Sorry, I'm trying to make it so I can... There we go. Okay, we're good to go. Chapter 5, normal curve. Probably some of the hardest things for people right here is being able to read the graphics. So let's go ahead and make some of our own graphics and do some of the hardest parts here to start. I think some of the easier things are z-scores and such, but let's go ahead and go to our best friend, Mr. David M. Lane. Now, you don't use the applet on the test. You don't use the applet on the test. You don't use the applet on the test. You may have to look at pictures of the applet on the test. So you may have to look at pictures of the applet on the test to solve problems. We're going to start off here with some level 2 questions. So let's make up some level 2 questions. I'm going to go ahead and make a graphic right here and bring it over to the main screen. And this is going to be a level 2 question. So get ready for this. Level 2 question. Okay, graphic almost ready. And let's say the following. If you read a question and it says the following. Using the empirical rule, then it's going to usually say this. Does it? I don't know. It can say empirical rule, technically. A test has a mean of 80 and a standard deviation of 5. What % of students are expected to score higher than 90? Okay. Test has a mean. Okay. See if you can solve this right now. And I've got a helper graphic on the screen. So go ahead right here, see if you can solve it. Now, when we say using the empirical rule, close, Ashley, close. I see where you're getting that from. That is one of the numbers, that is a subset of the numbers on the empirical rule. So what's the first thing you do when you get one of these questions? I've already done your work for you on this one. I'm going to start doing less work and less work here. What's the first thing you do when you get one of these? You draw it out. Draw it out. That's what we do right here. So we're going to take and we're going to draw the curve as we've done here. Yeah, we draw it. Boom, you got it right there. And then you're going to go ahead and usually I like to put in my z-scores below this. Now, we are going to go between z-scores of negative what and positive what? Z-scores between negative what and positive what? Z-scores of negative what and positive what? Well, Matthew, correct. We'll draw the full thing. Let me throw Matthew some points right there. That's how far the full thing is drawing. Correct, Matthew, right there. We're going to go between... I don't want to go 2 screens. Perfect. We're going to go between -2 and 2. And what percent of area... What percent of area is between -2 and 2? You might say, well, that's not your answer there, Brian. We want the percent of students who score above a 90. We put the mean at the center of the curve. So always put your mean at the center. The mean was 80. Standard deviations is the unit you should go up each time. There's the units you go up. And so now 95% is between here, because that's the second number on the empirical rule, standing for 95% of observations. We would expect students to get between a 70 and a 90. Savannah, great job, Savannah, yep. And then what is total outside of here? What is total outside? Remember, we do as many questions as we can. We're doing... Please tell me if you're stuck. So now what is total outside? Troop T is on the right track. Total outside is 5%, and then I think people are solving for the remaining 2.5. And just be very careful. It's easy to mix up numbers. 2.5. Now, this is using the empirical rule, and anytime you see something that says use the empirical rule, do this. We're looking for the empirical rule numbers here using 68, 95, 99.7. But what about if the question were to be slightly different and it were to say something like, what percent of students are expected to score below an 88? So now let's go take a look at this and find out what percent of students. So same question. I'm just going to grab the stuff right here. And let's put it in here. Really? I'm going to lose my mind. There we go. Come back. Was it too big? Ah! There we go. That's exactly what we want. Okay. What percent of students, and we're not going to use the empirical rule, using the graphic below, a test has a mean of this, standard deviation of this. There we go. So using the graphic below, what percent of students are expected to score below an 88? Sorry, getting the question ready. Below an 88. There we go. So I think you Z-scored it, did you? Good. Ashley, great job. That's the Z-score, right? So what percent of students are expected to score below an 88? So take a moment. I don't want to say the answers. I want you to think about it. No one's got it yet. How are you finding that? So anytime you get a graphic like this, you want to immediately think about what you're seeing. What we're seeing right here is we are seeing the percent of students who are expected to score above an 88. That's what we're seeing right here. That's what this is. And this is equal to 5.48%. Does that make sense? So then what do we want to find? We don't want to find that area. This is the question we're interested in. We're interested in this. So who sees Kelsey? Got it. Kelsey's got it right there. Kelsey's showing how to mathematically solve it. So as Kelsey's pointing out right there, exactly, and there's the number right there. Was someone saying, where's the number? Something. And so this number right here, if people are wondering, is this number right here. Because we're looking at above an 88 is 5.48%. And then over here, we're just going to take and do 1 minus 0.0548. And there's the 94.52. There will be pictures. Yep. There will be pictures, and knowing how to read them is very important, and understanding what you're getting is very important. Great question right there. 94.52%. And that's what we have right there. So that's how we'd find that one. Now, one thing I like to do is always I like to put the Z-scores here. So now let's make it more difficult and do the following. We'd have to use the empirical rule like the first one, or just give you pictures. So Zayed, good question right there. How did you get the 5.48? It's given right here. Great question, Griffin. The problem would show it, so make sure you see that it's above 88%, and then we know that this is the area above right here. I've got them highlighted in yellow to kind of show. Exactly, Kayla. Thank you so much. You are correct. Yep. I won't. You'll have to do these with the applet or something like that. We won't give you ones you have to do by hand like this. So good questions. And then let's do a more difficult version. Please ask questions if you're stuck at any point, because I'm kind of upping the difficulty each time. Let's change this same question, but let me show you this. Okay, so now I'd like to ask you, let me ask you this. What percent of students are expected to get below, my brain has to think. What percent of students are expected to get below an 82? Below an 82. So what percent of students, as I get the question ready, are expected to get below an 82? Take a moment. And what does Brian always do when he goes to his applets right here? Whenever I get a picture, I'm going to start drawing on it. You won't use the David M. Lane on the exam. You will look at pictures, though. You won't use the David M. Lane on the exam. You will look at pictures, though. So what percent of students are expected to get below an 82? Would seem like the logical thing. Kayla, 100 points right there. Kayla, you are correct. Would seem like the logical thing to do with this picture, right? Exactly, Muhammad. Great. Muhammad, that's worth another 50 points or 20 or plus 10. There you go. So let's go ahead and write right here 80 and 85. And what do you notice? What do we have on this curve currently? This is a good review of the topics. What do we currently have on this curve? We currently have what values on this curve right here? This is called the standard normal curve. That's a good thing to know. Kelsey, great job right there. Another 20 points, Kelsey. This is called the standard normal curve. Ashley, great job. And Kayla and Jack, great job. This is called the standard normal curve because there's a mean of 0 and a standard deviation of 1. I call this other one the context curve, which is the context of the problem. Now, the standard normal curve is going to give you z-scores. So this number down here is a z-score. So what score is being displayed on the curve right here? What score is being displayed on the curve? What score is being displayed on the curve? So that 0.4 represents a score of what? And I'm going to raise the difficulty again on this. That score being displayed is a score of what? So think that person is 0.4 standard deviations above the mean. So you know that person's score exactly above an 82. Does that make sense? So, and then exactly Savannah Singer right there, because what this means right here is this person is 0.4 standard deviations above the mean. So you'd have to say, well, the mean is 80, and we're going to add to that 0.4 standard deviations. And this right here would equal to 82. Does that make sense how we're getting 82? That we know the person's score is 0.4 standard deviations above the mean. So thus, we take 0.4 times it by the standard deviation and add it to the mean because they're 0.4 standard deviations above the mean. Just think about it as you say that. You're like, oh, they are this many standard deviations above the mean. So let's mathematically calculate that. The z-score right here, great question, Kayla. The z-score right here, because this is on the standard normal curve, make sure you notice that this is a standard normal curve with a mean of 0 and a standard deviation of 1. So that right here, this value right here must be a z-score because it's on the standard normal curve. And then to get the value of y, we can do the mean plus the standard deviation times the z-score, which you see over there on the right side. Does that make sense? The 5 is the standard deviation of the original problem. Great question right there, Jasmine. The 5 is the standard deviation of the original problem. So to highlight those numbers right here, this is the mean. And the original problem said the mean is 80. And then the standard deviation right here, I reversed them. Just so we can have mathematical consistency. This is the z-score. Yeah. There we go. And then the standard deviation right here is 5. And that's the distance these numbers are away. Does that... So did we... David M. Lane gave us the point, or the 0.4 was entered in. Does that make sense? Exactly, Jasmine. Jasmine, great job right there noticing that. Yep, we're taking 0.4 of one of the standard deviations, so we're going 0.4 standard deviations above. So is that making sense, Jasmine? Excellent work right there seeing that. Sometimes there's just click moments sometimes. Like seeing the math can help or seeing the equations can help. But seeing, like, hopefully the color coding helps too, to see like, okay, Brian's put in yellow the z-scores, the standard normal curve, and then you've got the means highlighted in pink right there, and then you've got the standard deviations highlighted in blue, and then we're just going up 0.4 standard deviations. Oh no, wouldn't figure it out myself. Now let's make this more difficult. You ready for this? Here is the level 10 question. We've been going up in difficulty each time, so if you've been following along perfectly, excellent work. The biggest thing, yep, I'll upload it. We can probably get to the SI chat. I'll get it to Alyssa if not. But if someone from my class uploads it, that'd be great too. So now, let's do this. This question seems like a level 10 question, but it's not that hard, and it's using the following graphic. Once you see the answer to this, if you get it, you'll be like, oh my gosh, you'll be like, that was so easy. What do you think is something you could do right now to 78? Remember, we're going to draw our numbers, right? So I'm going to go here and I'm going to put 80 at the center. I'm going to put 85 right here. I think you're right, Kayla, right? Kayla, do you already see it? And did you already get it? So what happens when you change 78 to a z-score? So let's make 78 a z-score. People are seeing it. Let's take 78, make it a z-score. And so 78 is a z-score is observation minus mean over standard deviation. The formula for a z-score, once again, is the observation of y minus the mean over the standard deviation. So that's what we see right here. We get negative 0.4, which means it's down here. And that means we're looking for the area above there. But I want you to see something. What do you notice about this area in yellow right here? Now, we want the area above here, but what do you kind of notice about that area in yellow right there? What do you notice about that area in yellow to the shaded area on this graph? Because I think Kayla's already seeing it. And if you saw it that quickly, these level 10 questions are a lot lower. Kelsey, great job. It mirrors the other side. So that means you know that the area below here is what? Like, you already know that this area here is this, and this area is a mirror of it because it's the same z-score. Like, it's the same z-score, it's just on the other side of it. So that area there is the same. So that's 0.3446, and we want the area like over here completely on the other side of it. So we're interested in this area here. It's a little hard to shade it because it's already shaded. So, oh, I might actually be able to do it. So what do we do? Yep, that would be where the observation is at. That's where the observation is at. Great job right there, Jasmine. That's the observation. And then I think Ashley's got it great. There's so much mathematics there. Actually, I was like, that looks correct. And we're just subtracting it from 1. We're just subtracting it from 1. And make sure to do Troop T gradient. Make sure to subtract the 100%, because basically the whole curve is 100%. And then you're going to subtract that out of 1, because 99.7 is only plus or minus 3, and the curve goes further out. So 100% minus that right there. Or be careful, 1 is in a decimal too. So Troop T, excellent work today. Keep it up. And then look at Brianna's answer right there. No, this is great answers right here, and I think people are getting it. Kayla, does this make sense? This was about as tough as the questions I can write, and we went up levels of difficulty each time. What are people thinking about this question? We're going to do a few more things here in chapter 5, but this really comes down to practice and to where you feel comfortable. Like, I haven't even done a percentage one yet. Who felt comfortable with this question? Like, it made sense as we solved it and we turned that into a z-score. We saw the symmetry of it, And then we said, well, okay, we'll just, the same thing would be on the other side. And we want to find the area above this now. So 65.54 is the answer. Andrew, great job right here. These are like, this right here is where you're getting it. And definitely your practice is paying off. Like, remember, I promise you this, remember for later chapters that it comes down to practice. First time seeing this on the test, you're like, what? See it a bunch of times, it makes sense. Awesome, right job right there, Jens. Excellent work. Let's go on to another one. Oh, you bet. Let's do it. Like, review it one more time. Yeah, let's do a different one. Okay, so still on the level like 8 of difficulty. So we're doing the same sort of values, mean and standard deviation for all of these. You're excited because your test came back in the top 10% of grades. You're excited because your test score came back in the, no, let's not do top 10. Let's do top 1%. Okay. Give me a second. You're excited because your test score came back in the top 1% of grades. What did you score? Okay. Same distribution. And so we just take this right here. You're excited because your test score came back in the top 1% of grades. Excited. You are the 99th percentile. You're at the 99th percentile of grades. What did you score? So you are in the 99th percentile of grades. What did you score? So stop doing that word. Okay, I gotta make it a little smaller. You're in the 99th percentile of grades. What did you score? We want the hardest question. I'm trying to make them harder. I'm trying. People are solving them. You're in the 99th percentile of what you score. So who can use the information on the screen and how does it help you right here? You are in the 99th percentile. And remember, the test has a mean of 80, standard deviation of 5. It's really going to help to draw your numbers. You want to take and immediately start drawing your numbers. We're using the same numbers because they can be any numbers. So careful. You are maybe. Well, let's see what people get. So what information are you given? Who can narrow down the information you're given? Look at the information you're given and think about what this is right here. Can you explain what that is? Mohammed, you're on the right track visually. You're on the same, so you could estimate it right now. So now you've got an estimate. That's a z-score. And it's the z-score for the what percentile. That is correct. That's a z-score. That's the right track. This is where we want to go with it. That's a z-score. So we know that that's a z-score, and it's a z-score for the what percentile. You're on the right track. You're doing everything correct right now. Okay, that's a z-score. That's a z-score for the what percentile. The first percentile, Abby, great work right there. So since that's a z-score for the first percentile, what do you think you could deduce from that? Because I think it was Muhammad was saying, well, wait a minute. Let's just go over here because he said the same but the other side. So what do you think we can do with that? So think about, Kayla's starting to see it. Kayla's like, wait a minute. If it's the same but the other side, and that's a z-score, then what could we do with it? I'm trying to pull out some of the hardest questions I can pull out right here. So it's the same, but on the other side, I think someone figured it out. I think Andrew figured it out. Ashley's got it. Yep, reflect it. And now it's just the positive. Ashley and Andrew right there. Andrew might be right. And it looks like Jack's confirming that Andrew is right, unless everyone's getting it wrong, but probably not. So now we're just going to say it's 2.362, and a z-score tells us what? It tells us how many whats. Just think about it mathematically, what you're going to do. That z-score is telling you that this person is how many whats above the what. Celine's getting it right there. Great job, everybody. That's how many standard deviations they are above the mean. So now let's go here and take the mean and add to it that many z-score standard deviations. This will give us the observation. Y stands for observation. So the mean was 80. The z-score is 2.326. We found that because we're just doing the other side of the curve. The bottom 1%, the top 99%, top 1% are in the same spot. And the images would be given on the exams. We don't expect you to use the applet. Great job right there, Ashley. And then this right here is going to be 5. And people are confirming. I'm going to trust everyone in the chat that it's 91.63. We'll do one more, then we mention a few more topics. Does that make a lot more sense right here? Who's thinking that makes a lot more sense right here? Like, okay, that makes a lot more sense. Like, okay, good. Oh, I'll do one more. Like we can do, let's bring it a little bit easier. Here, wait, where'd our graphic go? I'm hoping that's making sense. You just have to practice these. You have to know what you're seeing. Oh, no worries, Kayla. Don't worry. It's practice, practice, practice. So I'm just trying to do as many. If everyone said they were lost, I would like go back and we're gonna do a lot more review. We'll be doing review during tests. No unsolvable ones. Savannah, such a good question. If it's unsolvable, we made an error, and we will feel bad about that. Your friend feels bad though, because your friend scored in the bottom 20% of this test. So what did your friend score on the test? Your friend feels bad because they scored in the bottom 20%. What did they score on this test? Your friend feels bad. This is a quicker solve. We went back to like a problem of difficulty 5 or 6. Your friend feels bad because they scored in the bottom 20% of the test. What did they score? That was the equation to solve for the observation, Kylie. A good question, which it is the mean plus the standard deviation times the z-score is to solve for the observation. Thank you, Kylie, about that. Good question. Your friend feels bad. They scored in the bottom 20%. Your friend feels bad. They scored in the bottom 20%. What did they score? Who knows? So this one's a little bit easier. You just have to know what you're given. Right now, we're reviewing the what percentile. I should have maybe said this more often. No, instantaneously, we're reviewing the what percentile. We have the top 20%. Muhammad, excellent work. Reviewing the top 20%, also known as the what percentile. So if we are viewing the top 20%, the question doesn't ask about this, but it's important knowledge. The top 20% right here, if we're viewing the top 20%, that is the 80th percentile. Excellent work right there, the 80th percentile. So with this being the 80th percentile, then how could you find where the 20th percentile is at? Well, think, we have a distance right here. There's a practice test question like this. How much is this distance worth right here? If I call this x, how much is that distance right here? So remember, the mean is at 80. And this goes up to... So how much is x worth? People are... Andrew, great answers, Andrew. Yep. So how much is x worth? How much is x worth? 4.28. 4.208 to be exact. We'll call it 4.2 to be nice. Here, wait, 2 seconds. That makes my life a little bit nicer. Who sees how we're getting 4.2 right here? Does everyone see why we're getting 4.2? We're just saying how far above 80 is 80. Does that make sense, Kayla? It's 4.2 above. Does that make sense? This distance right here from 80 to 84 is 4.2 above. Do you see that right there? And so we won't need to make this one a z-score. Go question, Jasmine. We won't need to make this one a z-score because right now it's in the actual units. Well, okay, so this right here, let me write above. This spot right here is at 84.2. And then this middle of the curve right here is at 80. And then the distance between them is 4.2. Does that make sense? Ashley, you're seeing it. Does that make sense where I got the 4.2? Because the mean is at 80. And then this right here, this is where we're at. Like this value is this value right here. That's the, yeah, so yeah, I love it. No, it's slow me down. Say I gotta wait, I gotta see this. That's how far we are above. And then I think people are seeing it. Well, if we want the bottom 20%, what do? Because we don't want this. We want over here, right? So who knows? Does it make sense what we do now? So now what do? So now we would take this. Really? I want to move it. There we go. And we're just going to take... There we go. And we're going to do the same thing, but subtract. No cry, no cry. Muhammad's got it right there. We're going to subtract. We're just going to go the other direction. Does that make sense mathematically? So the answer will be to subtract from 80 and get 80 minus 4.2, which is going to be 75. Yeah, exactly. It's a reflection like the last one. Exactly. Because the top 20% or the bottom 20% are the same distance away from the mean. So all we're finding is the distance, how far this is above. And then we would just subtract that distance right here. So the answer is 80 minus 4.2. And you should get 76 point. Oh, no. Brian can't math. 75.8 or so. I'll disappear. There are so many numbers. Oh, no worries. These are, I was trying to I went up to some of the harder questions. This is TET. Top 20%. Exactly. Matthew, thank you so much. Matthew, keep explaining. Sometimes it can really help. Oh, Kayla. Okay, good. I thought someone was making fun of you. I was worried. I was like, don't make fun of each other, but you're allowed to make fun of yourself. Yeah, this is your friend right here. Your friend scored. They scored in the bottom 20%. So we know where the top 20% is. So then we're flipping it to find the bottom 20%. Does that make sense? We find out how far it is above the mean. And then we find out, well, since the top 20%, it just quit. We're still streaming, right? Still here, right? I think we're still here. We're here? Good. I heard it just quit or something like that. I'm worried. Let's mention two other things. Two other important things to know is we can look at normality with what is called a normal probability plot. Oh, no. Oh, it might have just been YouTube being weird or campus Wi-Fi. Not that campus Wi-Fi would ever be horrible. So this right here, because we're going to have to go to correlation here in a moment. I'm going to grab some food between our stream right here. So this right here is known as a normal probability plot. What does a normal probability plot allow us to do for a distribution? What does a normal probability plot allow us to do for a distribution? What can we use a normal probability plot to look at for a distribution? Normal probability plot, read it backwards. When you see normal probability plot, a normal probability plot is a plot that analyzes the probability of something being normal. Correct, Caroline. We're going to see if it's normal. So when we see this right here and it follows the straight line, that means it's pretty normal. But when we see a normal probability plot that is bent like this one, this other one here, then this means it's very what? This normal probability plot up here is very bent, which means it's not normal. And correct, Olivia, correct, because if it is normal, Olivia, I'm throwing you some 50 points right there. If it's normal, we can use the empirical rule, but if it's not normal, we can't use the empirical rule. So a normal probability plot is used to analyze to see if the normal model is appropriate. When a normal model is appropriate, the normal probability plot will follow the straight line. When it's not appropriate, then the normal probability plot will not follow the straight line, and when it is appropriate, it will follow the straight line. Now we have one more way of analyzing normality right here. And the other way to analyze normality is with what is called a goodness of fit test. And these are things people forget. The goodness or fit test is a test to see whether the data is normal. So we go over here to fit the normal curve, and then we run the test. When you run the test, you will see something below it, which is a p-value. This p-value right here, and this is one of the confusing things. The p-value is the probability of seeing what you saw or something more extreme given the null is true. Now that's a lot, but let's teach to the test for a moment. Teaching to the test moment. If the p-value here is low, that means we have evidence that this curve is what? If the p-value here is low, that means that we have evidence this curve is what? If the p-value right here is low, get rid of the null. You're right. And the null is that it's normal. So we're getting rid of that. We're saying not normal. Correct, Kelsey. And I'm going to show you a few examples in one of my favorite programs over here. Take a look. Let's go here. And I'd like for you to tell me, does this data look normal or not normal? Does that data look normal or not normal? That's a histogram, univariate quantitative data, normal or not normal? Normal or not? Oh, wait. Does it look unimodal, symmetric, really no outliers? For this, yep, Haley, for this instance, yes, for this test. There's other tests. So for a goodness of fit test for normality, low p-value is evidence of non-normality. So how should the normal probability plot, also known as a QQ plot, how should the normal probability plot look? Since this looks normal, how should the normal probability plot look? We have the same data, because we could make it in a box plot, but how would the normal quantile plot look? Normal probability plot. Because we could make a box plot of this, but how would our normal probability plot look? Straight. Does everyone see that? Now the goodness of fit test is going to have a high or low p-value. The goodness of fit test is going to have a high or low p-value. So remember, we saw that the histogram looked normal. The normal probability plot follows the red line. It's got a lot of names. And the p-value right there, Chloe points out, is going to be high. And look at that, a high p-value right here, indicating we continue to believe it's normal. There's a lot of different null hypotheses. More on that coming up. This one has the assumption, and it should be above 0.05. So this one's above 0.05, which is where we reject the null. Lots more on tests to come later in the class. This is the first time we're seeing a statistical test, and it's to test whether or not it's normal or not normal. And the null is that it's normal, so we do not reject the null. But what about if we had data that was not normal? Take a look at this data. This data is skewed to the right, which means our normal probability plot will be straight or not straight. The normal probability plot, which is a plot to analyze normality, is going to be straight or not straight. The normal probability plot, which is a plot to analyze normality, is going to be like bent. It's going to be like bent, right? So let's take a look at that right here and look at that. Not straight, which means not normal. And now the p-value for this new test will be high or low. The p-value for this new test will be high or low. The goodness of fit test to see if the normal curve is a good fit will come back very, very, very low. And look at this. This is, if you didn't know, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2. Oh, I forgot some zeros. I knew I was saying it 1, 2 a few times. There we go. That's what that is. That's a very, very tiny p-value because we have strong evidence that this is not normal. It does not follow the normal probability plot at all. Meanwhile, the ones that were normal did follow the normal probability plot and had a higher p-value. I think this is a part of the chapter that people often forget is the checking of normality. We're going to head back here to the main screen. We've got only a little bit of time, like 15, 20 minutes to talk from chapter 6. Let's do it. Woo! Oh my gosh. See, this is what happens when I take 2 minutes to take a break. We get a tiny bit behind. Let's go do some chapter 6. I was some chapter 5. You can't tell chapter 5 is a big one. Who's ready for some chapter 6? Do we still have like 100 people watching? Come back for the Kahoot if you weren't here for this. If you're not here, you're not hearing this right now. But chapter 6, we didn't do pivot. But let's talk some chapter 6. I think chapter 6 is an easier one. Come back for the Kahoot. Remember, $100 in prizes. Email me if you win the Kahoot. I'm excited to see who's going to win. We have a lightning round tonight at the very end. Double the points. You'll find out more about that to come. But for now, chapter 6. Now, some classes have covered this. We have not. This is going to be on Monday. I know. Where are you if you're not here? The biggest things to know with chapter 6 are when we do... So a low p-value means that it's not normal. In the goodness of fit, yes. Yep, Kylie in the goodness of fit test. Yes, the playlist going over, or the speed runs going over pivot. I would watch those. Sorry, Savannah. I realized we were running short on time, so pivot is definitely a lot of practice. So Savannah, email me if you can't find it. Message on the Discord, say hey, and we'll get it to you. Or the review. We have videos going over the pivot. Hashtag show up. Yes, everyone here's showing up. Okay, so correlation has 3 conditions. QQ, straight enough, no outliers. There we go. The Kahoot will be in 22 minutes. So right here, QQ is known as 2 quantitative variables. Straight enough means straight line goes through the data. No outliers means, wait for it.
Wow.
There we go. I like to say QQ, which is 2 quantitative variables. So you will usually hear it called 2 quantitative variables if someone other than Brian is teaching it. 2 quantitative variables. So let me ask you this. Could we do correlation with people's gender and their GPA. Could we do, dinner? Go grab some dinner. Could we do correlation between people's gender and their GPA? Yes or no? Could we do correlation between people's, why, Zaid? You are right. Why? You are right. Marjorie, you're right. Why can't we do correlation between GPA and gender? You are correct. Everyone's saying no. Even Kayla came back to say no. Gender isn't quantitative. That is correct, because gender is categorical. I thought we couldn't use correlation at all in Stat 1. We are. Correlation is a relationship between two quantitative variables. Now, we would say we need to know that correlation... And frankly, anytime you see this causation word, that's almost like a red flag right here. Like, anytime you see cause, the coot will be recorded. See cause with the New York accent. Anytime you see causation, it's almost a red flag being like, that's a problem. We don't say causation unless we do an experiment. We don't really talk much about experiments in our class. So we don't really think things are causing things unless we do a controlled experiment with randomized control and stuff like that. Randomization and a control. Oh, no worries. No. So we would never say cause. Yeah, we wouldn't say correlation causes anything. Now, when it comes to two quantitative variables, there's specific ways we talk about. So how do we talk about, let's put it right here. How do we talk about two quantitative variables? We have 4 keywords, and the 4 keywords are strength, direction, form, unusual features. Okay, this is a review question. How do we talk about one quantitative variable? How do we talk about one quantitative variable? Here's how we talk about two quantitative variables. Does anyone remember how we talk about one quantitative variable? This is how we talk about two, and I'll explain how to do this here in a second, but this is two quantitative variables. If we had one quantitative variable, how do we describe one quantitative variable? Like if you have a histogram that's one quantitative variable, so how would you describe a histogram? With what words? You talk about the this of it, the this of it, the this of it. So this is to contrast something you've already learned. The shape, center, spread, Brianna, great job right there. The shape, the center, the spread for one quantitative. So when you have two quantitative variables, you have an additional one. We're going to start with the very easiest one to do, and it's direction. Direction will be either, well, actually I did that by accident, but I was right. It'll be positive, negative, or neither. So think about this. Positive, negative, or neither. So with this right here, you could have something that goes up. You could have something that goes down. Or you could have something that is not well described by either. So does that make sense here that direction is, does it go up, does it go down, or it's not well described by either? Does that make sense right there? Positive, negative, or neither. That's the direction of the way the correlation goes. Now, we have form, and this is an easy one. It's either linear or not linear. So it's either a line or it's not a line. So the form is either a line or a not a line. So you can see something that looks like this is a line versus something that bends is not a line. Now we get into the last one, which is a little bit easy too. Unusual features. What do you think an unusual feature is? I want to see the chat go crazy with this. We lost a bunch of people, but we still got it. Don't worry. An unusual feature is basically a what? I should put it right here. Outlier, Brianna right there. Excellent work. Some points right there, Brianna. And excellent work, Matthew and Celine and Ashley. So these are things that do not follow the trend right here. And we have outliers, are these unusual features right here are outliers. So now we need to talk about strength, which is one of the more confusing things. So measures linear strength, or no, I shouldn't put that. Think about correlation already. Measures how tight the points are around form. Well, that's good. Around the form. Okay. Strength is probably the most complicated one because let me ask you, which of these is stronger? And this gets into some good topics right here. Which of these is stronger? Graphic A, I haven't drawn anything yet, or graphic B? So which of these is stronger? Which of those is stronger? Graphic A or graphic B? Which of those is stronger? It is graphic B. Which of these has a higher correlation? And this is where the questions get hard. So B is the strongest, but which of those has a higher correlation? Can I bring the whole thing to a new page? Let's find out. Which of these has a higher correlation? Oh, I did. So B is stronger. A has a higher correlation because correlation only measures linear strength. Good question right there. I see Muhammad has a question. So B is stronger because the strength is how tight it is. As in these points right here, and I'll draw some more. Do you see how these points are tighter? Like if I were to draw the form, this one has a parabola, and those points are tighter around the parabola than these are around the line. So do you see how those red points, exactly, I think Matthew's kind of pointing out right there. So B is stronger because it's tighter around the parabolic form. A is linear, it's weaker, but correlation only measures linear strength, and B does not have any linear strength. If I were to draw a line through this, the line, it's not around a line. Does that make sense? B does not fit around a line, thus B does not have any linear strength. It has a very strong parabolic form to it, but correlation only measures linear strength. That's awesome work right there. Yep. So B is stronger, but A has higher correlation. So you have to be careful. So here's some true-false questions. True-false. Something with a correlation of 0 has no relationship or association. True or false? Something with a correlation of 0 has no relationship, no association. They're same words. Something with a correlation of 0, which is the value of R. Ooh, we're like 50-50 right now. So if I really don't do that to me. Oh. So wait. What is the value of correlation for B? I'll give you a hint. Correlation for B is equal to 0. Correlation for A is equal to maybe something like this. So look at this. This has no correlation, but does it have an association? Association means, if you know, Savannah's saying right there, it has no linear association, but things can have a non-linear association. Correlation only picks up on linear. So this is a good trick question right here. This was a tough one. We got a lot of people. So something with a correlation of 0 has no relationship. This is false because things with no correlation only have no linear. Now you will have instances. So we'll draw the two examples here. Something like this right here has a correlation of 0. You can draw around it, and that has no correlation. But then something like this right here might have a correlation like this, like some sort of time series thing, which you draw around it has a correlation equal to 0, basically. But now this one here in graphic 2 has some sort of association, like some sort of time order pattern to it. And if it has time order, it's a time plot, not a scatter plot. Is this making sense right here? Why something with a correlation of 0 can have an association or relationship? It's just that relationship is nonlinear. Values of correlation range between -1 and 1. -1 is perfect negative correlation. +1 is perfect positive correlation. So whenever you're thinking about it, your two strongest correlations are going to be what? What are the two strongest correlations? The two strongest, well, I drew the positive. Sure. The two strongest correlations are going to be what and what? The two strongest correlations are going to be what and what? -1 and +1. And the negative and positive only indicate the what of it. Like -1 and +1 have the same strength, they just differ in their what. Use the words from previous times. -1 and +1 have the same strength, they just differ in their what? Their direction. So they have the same strength, but they just have a different direction. So the absolute value of the correlation indicates the linear strength. So you can just take the absolute value of -1 and get 1 and tell that they have the same strength, and they'd be perfectly aligned. Once again, things that have a correlation of 0 have no linear correlation. I think we might end here. This is, I'm not even joking, this is most of the whole chapter. We probably just did 50-60% of what we're going to cover tomorrow. So don't be worried about tomorrow. We're probably going to do some Canvas content in class. If you've taken a look at this chapter online, it's not that bad. And we will be doing a lot of help in class. So make sure to attend class tomorrow. We're going to knock out the Canvas content. We're going to knock out all that good stuff. I'm going to end here for now. Grab a little bit of food. Not feud. But who's going to be at the Kahoot? I want to know right now. Hackerman's going to be there. Who's going to be at the Kahoot here in 9 minutes? Win some prizes. Yep, I'll be starting out that video here soon. Check out that link. Let me drop that link in the chat so we can get some people here. I need to go grab some food. Gotta get that food. Mega Kahoot review coming up. 14 people. Here we go. Kahoot in the chat. Let me go send that link out. But I'll be back. I'll be seeing you here soon. Bye for now, everyone. Bye.